Welcome to Vedantu NEET English. I'm Diksha Ma'am, your chemistry master teacher. Everyone in the chat box, am I visible? Am I audible to you? Yes, everyone in the chat box, am I visible? Okay, so hi everyone, good evening. And as you all know, we have started physical chemistry, and till now we have completed some basic concepts of chemistry in detail. We have completed structure of atom. Today we are going to do thermodynamics. Tomorrow we are going to complete chemical equilibrium and ionic equilibrium. Both chapters we are going to complete. Actually, that is a one chapter. But out of that, ionic equilibrium is very important, okay? And this thermodynamics is very important. Usually what students do, they skip this chapter. You know, thinking that, okay, maybe just one or two questions will be asked from this chapter. But what is the reality? Because of the decrease in your syllabus, they can ask question, right? Around 3 to 4 questions from thermodynamics, right? So, and realizing that this chapter is also in your physics, okay? You need not skip this chapter, because if you skip this chapter in chemistry, you will also skip this chapter in physics, right? And this counts to a large amount of marks. So this is not a very difficult chapter, very easy chapter, just some basic concepts and formulas, that's it. The numericals that are asked from this chapter are also very easy, simple numerical, simple formula based questions are asked from this chapter. You just need to, be clear about the sign conventions that are used in chemistry and the sign conventions that are used in physics, right? And all other things are work done. There are different formulas of work done. You need to know that which formula should be applied where, right? So all those things are very important for you. And bacha, today we are going to complete thermodynamics and thermochemistry as well. Both the things that we are going to complete today. So are you all ready, everybody in the chat box? Yes, bacha, are you all ready? Yes. I can't see you. Yes. Okay. Ma'am, this includes thermochemistry also, ma'am. Yes, bacha. Yes, NEET aspirant. Yes, that is going to also we are going to do thermochemistry as well today. Okay. Both the things we are going to complete today. Yes. Okay. Perfect. Everybody, green hearts in the chat box. Green hearts in the chat box. Yes, okay, so let us start. See, I know your time is very important, so I am not going to waste even 1 minute, okay? I am not going to waste that. I know this month is very precious for you. By next month, we are going to do the practice sessions and so many questions, so many predicted questions. But before that, I am going to complete your syllabus. I am not saying, okay, your syllabus will be completed mid of April. No. I am going to complete your syllabus within a week or so, like within 10 days or so, right? Okay, so I just need your dedication, right? Your consistency. That's it. That is needed from you. That's it. Okay, so let us start the chapter, that is thermodynamics, starting with everything. I also have one formula sheet for you where you will get my handwritten formulas, okay? All the formulas combined in one sheet, right? Okay, so now let us see thermodynamics. What is actually thermodynamics? Bacha, thermodynamics is the study of heat. Therm means heat, dynamic is change, right? So it is basically the study of heat, right? So the study of heat, that is thermal, and work done, that is dynamics, it deals with energy transfer during the chemical and physical changes, right? All the energy transfer, you are going to talk about heat changes, work done, all these things we are going to talk about today, right? Okay, so that is the name, right? Now, what are the terms? There are 3-4 basic terms for it. First is what is universe, system, surroundings, and boundary. For example, you are making tea. So when you are making tea, in that case, okay, you are making tea, right? Okay, for example, this is your beaker. Okay, this is your pan or beaker, right? And in this you have your water and all those pattis and all that, okay? All those things. Now, here you have, this is closed, right? So now, that thing which is under observation, you are observing this part, okay? You are going to observe this particular part. This part is under observation. The part that is under observation is called system, okay? That may be anything, right? The part except for system. Okay, universe is everything. Everything around us is universe, including us. Everything is universe. Out of which system is that is under the which we are actually which we are determining to see what is happening, right? Which is under observation. Now, what is surrounding? When you minus in universe, when you accept when you minus system from the universe, that is called the surrounding. Okay, right? Okay, that is system and surroundings. Now, what is the boundary? Okay, what is the boundary? This is the system, and everything except for system in the universe is called surrounding, right? And this boundary that is differentiating system and universe, system and surrounding from this universe is called the boundary, right? Okay, simple terms. Now, next thing is another basic terms from which the questions are asked, okay? That is open system, closed system and isolated system. So now let us talk about open system, closed system and isolated system. See, this is a beaker, this is a beaker, this is a beaker. Now, everyone in the chat box, okay? This is a beaker and this is the water, okay? You are making Maggi, you are making tea, whatever you like, okay? But now, you are heating it. You are supplying heat here, okay? You are supplying heat here. Now, when you are supplying heat in an open system, when you are supplying heat in an open system, what happens here? There is exchange of water vapors. Water is converted into water vapors. That means there is exchange of mass, okay? There is exchange of mass here. Second thing is, there is exchange of mass. Second thing here, what we see, that we are providing it heat, right? So there is transfer of energy also, right? There is transfer of energy also. So we see mass is getting changed, right? There is transfer of mass and there is transfer of energy, right? This is the first thing, that is open system. Now, if you are heating it, if you are heating the water, but you put a pan, that is a closed, okay? That is a closed container. When you have a, when you put a plate or something, okay, something on the upper side of this, right? That means something like this, okay? Now, there is no possibility that water vapors, what will happen? This water will vaporize and the water vapors will be present here, okay? They will be present here. Whenever you see in your kitchen, if you have boiled anything, even water if you have boiled, right? If you have boiled eggs or anything in your house, right? What you will see, when there is a closed container, what happens? We are giving it heat. There is moisture, there are water particles on the top layer, okay? You will see the water particles here, okay? That means there is no exchange of, there is no mass exchange. Mass is not exchanged here, right? But the energy is, heat energy is getting exchanged, okay? But the energy is getting exchanged in this. Yes, very good. Now the third thing is isolated one. What is this? Isolated. Isolated, how do we see that? Your thermos bottle, right? Your thermos bottle, the thermal bottle is basically where there is no heat exchange, okay? I have one bottle. In this bottle, if I say I put warm water in this, right? What will happen after some time? This will get cooled down, right? But in thermos bottle is made such a way where there is no exchange of heat, right? There is no exchange of heat. And mass, otherwise you cannot exchange because that is a closed container, right? Okay, so this is water and this is a closed container as well. But this is also having an isolated layer here, okay? This is a layer of, this is the isolated ceiling where there is no heat exchange, right? Where we see no heat exchange, right? So there is no heat exchange, no mass exchange, no heat exchange, no mass exchange, right? Nothing is getting exchanged here. But if we say, in reality, is this possible that something is 100% isolated? Now, if you have your thermos bottle and you say that, okay, I have my thermos bottle, I'll put water in it. After even 3-4 days, it will stay like warm. No, that will not even stay warm for 10 to 12 hours, I think, right? Maybe for 5 to 6 hours it will stay warm. It will like have little bit exchange of heat energy, right? So perfect isolated system is not possible in reality, right? Okay, yes, that is possible in labs and all, but yeah, that our thermos bottle is not perfectly 100% isolated. Yes, everyone. Yes, nor mass and neither mass nor energy. Yes, bacha. Now let us see the definitions here. Let us see the definitions. Can exchange matter as well as energy. Matter means mass with the surroundings. Can exchange energy but not matter. And isolated cannot exchange matter as well as energy. Right? Okay. Any problem? Now, bacha, next part, very important definitions, and what they ask you from intensive and extensive properties, they ask you out of this which is independent of mass, out of this which is dependent on mass, out of this which is an extensive property, out of this which is an intensive property. For that, not only definitions are not important. The thing that is important is the examples. Examples are very important for you, right? Okay, so now let us see what is extensive and what is intensive property. Extensive property is something that is independent of mass, that does not depend on the mass, that does not depend on the number of moles that you have, right? And extensive property is something that depends on the number of mass, the number of moles, that depends on the quantity taken, right? So here we will see how we will learn that, ma'am, because that is very confusing, right? I know that is very confusing to, retrieve that information in your exam. So how you will learn it? This is intensive. That means intensive means independent. Okay, intensive means independent. Okay, intensive means independent of mass. Very simple. Now let us see the examples of intensive properties. The examples here are, pressure, temperature, density. This does not, you will say, now density is equals to mass by volume. But bacha, this mass is an intensive property. Mass is itself, mass will be dependent on mass, right? This is an intensive property. And this volume is also an intensive property, right? More is the mass, more will be the volume. And we know one thing, that when we divide two intensive properties, the division here will be extensive, right? Okay, extensive. Okay, bacha? Yes, this is intensive. Wait. Mass is intensive. Volume is. Oh. I'm so sorry. Wait. No. I wrote something wrong here. Just give me a minute. Yes. This is intensive. It does not depend on. Yes. Okay. So now you have density is equals to mass by volume. Wait. You have density is equals to mass by volume, right? Okay. That is equals to mass by volume. Now let us see this. Okay. Now mass is actually extensive. Okay. By mistake I have written that. Okay. This is extensive property and this is also extensive property. Right, not intensive property. Yes, this is not intensive property because, for example, you have like n moles here. Okay, you have n moles here that can also occupy this volume. If you expand this, n moles can also occupy this volume. Okay, n moles can also occupy this volume. And if we talk about one single mass, okay, if we say mass is equals to 5 kilograms, this is not dependent on anything, any other mass, right? This will be 5 kilogram only. Right? Okay. But I am doing wrong here. Yes. Okay. So now this is going to be intensive. That means this is independent. This is independent. I think I'm right now. I don't know why I got confused here. Just give me a minute, right? I got confused here. Wait. Sometimes this happens, okay? Sometimes this happens. Okay. Yes. Mass is dependent. Volume is also dependent. Mass is dependent, volume is also dependent. No. Mass is dependent, volume is also dependent. Yes, okay. And the division of two extensive property is intensive. Yes. That is the statement here. Okay. I'm so sorry about the confusion. Okay, I just got confused in mass and volume. Okay, I just got confused in that. So that is why this density, if we talk about what I was saying, this density, I think before I was correct. Okay, now I was getting confused here. Okay, so let us restart this. Okay, let us restart this. So now density is equals to mass by volume, right? So density, we can see from the formula, usually what we predict that density is equals to mass by volume, that is dependent on the mass. But actually, this mass is extensive property, this is also extensive property, and the division of two extensive property is intensive property. Okay, the division of two extensive property is the intensive property. That is why we say mass by volume is intensive property. This is not extensive property, right? This is independent of this mass, this is dependent on the mass, this is dependent on the number of volume. Okay, this is dependent on the number of moles, this is also dependent on the number of moles, right? This is not dependent on the number of moles, right? Okay, so now this was about density and mass and volume, right? That can be asked in your exam. Second thing that can be asked in your exam is heat capacity, and we have 2-3 type of heat capacities. See, okay, if we talk about simple heat capacity, now heat capacity, what I'll say, this is dependent, right? This is dependent. Why this is dependent? We'll learn that in further, right? Because we are going to learn heat capacity in detail. Right now, what is important for you is that heat capacity is dependent on the mass, right? This is going to be extensive property. This is going to be extensive property. But if we talk about specific heat capacity, right? Or I'll just write it as specific heat capacity, right? Or we talk about molar heat capacity. These both heat capacities are independent, right? They are independent. Why so? Why they are independent? They are independent because here I am talking about 1 mole, right? Here I am talking about 1 kilogram. That is why they are independent, and here we will say that these are intensive properties. Okay? These are intensive properties. So this question also can be asked in your exam, that if they ask you heat capacity, that is extensive property. But if they ask you specific heat capacity or molar heat capacity, right? Specific heat capacity is heat capacity of 1 kilogram. Molar heat capacity of 1 mole. That is why these are intensive properties and this is extensive property. Yes, bacha? Okay? Yes, I got little confused there. I got confused, right? Okay? Right? That's why I have made this thing like intensive, independent, because this is very confusing. Right? Okay? So, here this can be asked. They can ask you this one, they can ask you this one, or they can ask you heat capacity. Right? If we talk about enthalpy, entropy, that we are going to discuss today, these two are also dependent on the mass, right? We will see through the formula that they are dependent on the mass, right? Okay, talking about melting point, boiling point, that is fixed for any substance, that is fixed. It doesn't matter what is the mass, right? Okay. Understood this? Yes, bacha. Now, next thing that we are going to do is basic terminologies. Now, let us see some basic terminologies, that is state function and path function. Now, what is state function and what is path function? For example, you have a thing that is, this is A, B, C, D, E. Okay, this is A point, this is B point, this is C point, D point, E point. Right? Okay, so if something is going from A point and coming back to A point, right? It is going from A point and coming back to A point, right? And it is independent of the path. Doesn't matter if it has followed this path or if it has followed this path, or we can say if it is coming from A and going to E, it has followed this path or it has followed this path. It doesn't matter. What matter is the final point and the initial point. That is called the path function. That is called the path function. And what about the state function? State function is that which is dependent on the path followed. That what path that you have followed. For example, I will say I have followed this path. Okay, state function will have different value for this one and different value for this one. Okay, so the path matters here, right? Okay, yes, bacha? Yes. Okay, now let us see the state function and the path functions here. Now let us see the state function and path function, okay, which depends only on the state of the system. This depends only on the state of the system, right? Doesn't matter what is the path and all, doesn't matter, right? Okay, so just simple thing here that work and heat, what you need to remember here is that work and heat, that we will use work and heat. These two are path functions, okay? These two are path functions. So what we will see for reversible process, for irreversible process, these have different values. But here when we talk about enthalpy, that is delta H, when we talk about delta S, when we talk about delta U, when we talk about delta free energy, that is delta G, all these things that we are going to study today, they do not depend on. That's why we say simply what we write, this final minus initial, okay? Why? Because they are not dependent on the path, okay? If this thing, if you have this thing, if this depends, okay? If it depends, like if I am saying I am going from A to E, right? Now, if I am saying that doesn't matter what path I have followed, right? The value for this one and the value for this one is same. That is going to be, if the value from, this is first and this is second. If 1 is equals to 2, then I am going to say this is a state function. This is a state function. If I say 1 is not equals to 2, then I am going to say this depends on the path followed, right? So I'll say this is a path function. And what are the path functions here? Always remember this. Work and heat are the path functions here. Everything else is the state function. We talk about what you talk about. Enthalpy, Gibbs free energy, you talk about internal energy, you talk about entropy. Okay, the change in Gibbs free energy, enthalpy, internal energy, everything entropy is not dependent on the path. Okay, understood this? Yes. Okay, now conformational isomerism. Yes, don't worry, I will do that. Okay, after completing the physical chemistry, I will have a one class of conformers. Okay, don't worry about that. Yes, now next thing bacha that we have is thermodynamic processes. Now we have total 5 thermodynamic processes. Let us see. First is iso. Iso means same. Okay, isothermal means when there is no change in the temperature. Isobaric means when there is no change in the pressure. Isochoric means when there is no change in the volume. The volume is unchanged, right? Adiabatic means there is no change, there is no heat transfer here. And cyclic is what? If you have started from one point and coming back to that point. Okay, that is a cyclic process. Now let us talk about all these processes in detail. Okay, in isothermal, delta T is equals to 0, here delta P is 0, here delta V is 0, delta Q is 0, and here all the state functions in cyclic process, all the state function will have 0 value. Why in the cyclic process all the state function has 0 values? Because if we talk about the state function starting from a point A and coming back to the point A, right? And we say this does not depend on the path. That means it is going to have the value of, for cyclic processes, write this, for cyclic processes, you are going to have the value of delta H, delta U, delta S and delta G equals to 0. Why? Because all the state functions are going to be 0 here. Okay, all the state functions are going to be 0 in this case. Okay, next is, let us talk about everything one by one. First thing is internal energy. Now what is internal energy? It is energy of that system. Okay, every energy combined is called the internal energy. Kinetic, potential, the heat energy, except for the heat energy, right? Kinetic, potential, all the vibrational energies, rotational energies of the molecule, everything in that thing, that system is combined together, come to the internal energy, right? Okay, if we talk about kinetic, potential, electronic, nuclear, rotational, translational, every energy combined together is called the internal energy. It makes the internal energy of the system. Now, talking about internal energy, we can never find the value of U. Okay? This is U is the symbol for internal energy. We can never find the symbol of internal energy itself, right? Absolute value of internal energy is not possible, but we can find the value of delta U, right? That we can find. Okay, that means, what is this? This means this is U final minus U initial. Yes, bacha? Okay. The table, which table are you talking about? Okay, this table. Bacha, this means isothermal. Iso means same. Isothermal means temperature is same, right? DT, that means change in temperature is going to be 0. Here isobaric means change in pressure is going to be 0. That is why delta P is. dP is 0, right? Change in pressure is 0. Isochoric means volume is 0. So dV is equals to 0. Volume means change in volume is equals to 0. Right? Adiabatic means there is no heat transfer. That is dQ is going to be 0. And we talk about cyclic process. In a cyclic process, all the state functions are going to be 0 in this case. Because we started from one position and came back to that position, and state function is not dependent on the path. In that case, all the state functions is going to be 0 here. Right? Okay. Now, let us talk about this thing. Signs of this. Now, if you say delta initial is more than this, okay, this is delta U is equals to delta U final minus U initial. In that case, if I say initial is more, that means delta U is going to be negative. If I say initial is less, right, final is more, in that case delta U is going to be positive here. Right? This is what they are saying, that energy is given out of the system. Whenever an energy is negative, that means it is released, it is given out of the system. Right? Whenever you give something, okay, you feel very negative, no, whenever you have to do some work or anything. Right? That is the case with this. If you have to give out something, it will feel negative. It has to, you know, if you get something, you feel very happy that I am getting something, right? So if energy is absorbed by the system, that is going to be positive, right? Okay? Yes, bacha? Now, internal energy depends on the temperature. Now, how internal energy depends on the temperature? If I say that temperature is 0, that if I say delta T is equals to 0, right? Then automatically delta U will account for 0. Now we will have a proper formula for that. We will derive the formula for this, right? Then whenever temperature change, that means for isothermal processes, delta T is 0. There is no change in temperature. In that case, internal energy is also going to be 0, right? Okay? Yes. So pressure, this is this. So it is a state function. This is going to be a state function. In most stable form, the internal energy of the system is 0. That means if we are talking about the most stable, when the molecule or the system is in the stable situation, that means it does not have any energy, right? So internal energy is going to be 0, right? Next thing that we have is heat and work. Firstly, let us know about sign conventions of heat and work. After that, we will study the first law of thermodynamics, right? So let us talk about heat and work here. Heat is what? When we give the temperature to something, okay, the temperature increases, right? We are providing the heat or we are taking out the heat. That is the heat, the temperature, not basically we can say the temperature. When there is rise in temperature and there is increase in the temperature, the heat energy increases. That we can say, right? So there are two ways by which a system can interact or exchange energy with its surroundings. So two systems that we have, one is heat, second is work, right? Okay, one is heat, second is work. Except for heat, everything else is the work. Everything else is work except for heat. If it is changing, thus if the system is changing the heat, right, that will be considered as heat energy. If it is changing some other amount of energy, that will be regarded as the work done, right? Okay, so now let us see What is heat? Right? Heat is a mode of transfer of energy between a closed and its surrounding during non-mechanical processes. Right? When there is non-mechanical processes, energy that is transferred from one body to another as a result of temperature difference. Whenever we have the rise in temperature, lower of temperature, heat energy is released. When there is rise of temperature, the heat energy is given to the system. Right? Okay. Now, let us see the sign conventions for this. Very simple sign conventions. You know, in your daily life, what you do when you have to give someone something, right? Or you have to take something from someone. Now, when you give someone, okay, you have prepared your notes, okay, or we can say you have prepared your favorite dish, okay, by yourself. You have prepared favorite dosa or anything by yourself, idli by yourself. Now what you are thinking that I have made this, okay, I want to eat this because I have made just a very little quantity, but some guest came over. Now you have to give the dish to them. You will feel like, oh, negative, like, oh my god, I have prepared, I'm so hungry, I have prepared specially for myself, right? So what you will do, you will feel very negative. When you have to give out something, you have to release something, you feel negative. And when you have to take something, you went to someone's house and they have prepared, you know, very tasty dishes and all that, you will feel very happy, right? You will feel very positive in that case. Okay, I'm very happy. Okay, I have, you know, I'm eating like tasty dishes without doing anything, right? So that is the concept of heat, right? Okay, that is the concept of heat. Very simple. Okay. Will hide it when someone came. Yeah, this is also what I do, right? What if your mom tells you, no, you have to give it to them. You'll be, oh my god, why I have to give it to them, right? So next is work done. Now same thing with the work done. Now when you have to, first let us see what is the work done, okay, then we will see the sign conventions. Any energy transfer which is not heat, okay, which is not heat, anything else, any energy transfer is called the work done, okay, that is called the work done. Now it can be of many types. There can be mechanical work, gravitational work, electrical, and so many other types of work, right? But in this chapter, what we are going to study is expansion work, right? That is minus P delta V. This is going to be our formula for work throughout the chapter. All the other formulas are derived from this formula, right? They are derived from this formula. So what you are going to remember, that work done is equals to minus P delta V, right? Now let us see the sign conventions for that. So for example, there is this gas and you are compressing it. That means work is done on the system. Whenever someone is doing work for you, okay, you don't have to do work. Someone is doing work for you. You're very happy because someone is doing it for you, right? Okay. Now, what I'll say, whenever there is when there is work on the system, when there is work done on the system, then I'll say, any idea? This is by the system. When the system has to do the work. Now, when your mummy or your father or your sister, brother, anyone says that, okay, make this for me, okay, bring a glass of water, you feel, oh my god, I have to, you know, get up and, you know, get the glass of water for them. You will feel very negative, right? You feel very lazy at that time. So when the work is done by the system, this is negative. When the work is done on the system, this is positive, okay? When the work is done on the system, that is positive, right? Okay, so here what we'll say, work is positive and here work is negative. Work done on the system, work done by the system. So these four sign conventions, I'm writing it here, very important. Firstly, if we talk about heat, everybody in the chat box. If we talk about work, everybody in the chat box, okay? So what we have concluded till now, okay, that heat when it is released, heat when it is absorbed, okay? Heat and if it is absorbed. Work when it is done on the system, work when it is done by the system. Now everybody in the comment section, tell me what is going to be the answer. When heat is released by the system is very sad, right? When heat is given to the system, system is very happy, system is dancing, right? When work has to done by the system, system is feeling very angry. I have to do the work, right? When system is not doing the work, the work is done on the system. Oh my God, system is very happy, right? This is a clear example is that when I say do this homework, you are like, oh, we have to do this homework. When I say, okay, I'll do that for you. You're like, yes, ma'am, do that for us. Okay? Then you feel very happy and here you feel very sad. Right? Okay? Yes. Now, is next formula, that is work is equals to, we are going to use this formula throughout. Okay? We are going to use this formula throughout. That is work is equals to minus P dV. That is the change in the volume, right? Okay, and also one more thing, that is PV is equals to nRT. This is the ideal gas equation. Remember this equation, okay? This is the ideal gas equation that we are going to use here. Yes, everyone? Perfect, perfect, perfect. Let me see. Yes, okay. Now let us do the question. Okay, let us do the question here. They are saying which of the following are not state function? They are not dependent on the path. Which is not dependent on the path? Only we say delta S, delta G, delta U, delta H. These are not dependent on the path. They are state function. When we say path function, what is path function? Heat and work is the path function, right? So see, they are talking about not state function. That means they are talking about the path function, right? So path function, that is Q and W. What is Q and W? Second and third. So here we have second and third. See, Q plus W. Q plus W. You know what is Q plus W? From first law of thermodynamics. What is Q plus W? That is delta U. Okay. From first law of thermodynamics, that we will do delta U is equals to Q plus W. So Q plus W is nothing but delta U. So this is also going to be a state function, right? This is also going to be a state function. So what we are going to write here, everyone, second and third is going to be the answer. So second and third, that means A is going to be the answer here. Very good. Next, bacha. Next is zeroth law of thermodynamics. What is firstly? Let us do the laws of thermodynamics. First law here is zeroth law of thermodynamics. Very simple law. What is this? They say if A is equals to B, B is equals to C, then C is also equals to A. Right? If A is equals to, if I say you are three brothers, you are three brother and sisters. Okay. There is what? There are three siblings, okay? Three siblings. First is, one is, you guys will, get irritated that, ma'am, why you make that one my brother or sister, right? So let us talk about, one is Rahul, okay? Then there is Meeta, right? And Rahul is the brother of Meeta, right? And we say, Meeta is the sister of Diksha. Okay. Now if I say Rahul is the brother of Meeta, right? Meeta is the sister of Diksha. So you know that Rahul is also the brother of Diksha, right? Okay. You will say Rahul is also the brother of Diksha, right? Okay. Yes, ma'am. Definitely. This is the same thing that they are saying. They are saying if this is in thermal equilibrium with this C, this is in thermal equilibrium with this, right? A is in thermal equilibrium with C, A is in thermal equilibrium with B, then B is also in thermal equilibrium with C. If A is equals to B, A is equals to C, then B is also equals to C. Okay, simple. Okay, very simple. Very simple. Okay, nothing to worry about this one. Simple law, yeah? Okay, so it's say that two system A and B are in thermal equilibrium with the third system. Then the system A and B will also be in thermal equilibrium with each other, right? Okay, yes, if they both are in, if B is thermal equilibrium with A, this is in thermal equilibrium with A, and these two are also going to be in thermal equilibrium, right? Okay, if A is equals to B, B is equals to C, A is also equals to C, right? Okay, now is the first law of thermodynamics. Yes, First law of thermodynamics states that, wait, just you don't need to do all that. Okay, first law of thermodynamics is very simple, that energy can neither be created nor be destroyed. It can be converted to one thing to another thing. Now ma'am, what is the formula for that? Okay, you just need to know this formula. That's it. That is, or you can see how it is derived. See, this is UA. This is internal energy of system A. Right? When we have given the heat or taken the heat, there is heat change, that is Q. There is work done, that is W. After that, the internal energy become UB. Right? This is the internal energy. Now what we are going to say, that UB equals to UA plus this heat energy plus this work done plus this heat energy plus this work done, and this will go here, and what you will have, UB minus UA, that is going to be Q plus W. Now what we will say, this is the change in internal energy. This is what is the first law of thermodynamics. Nobody is going to ask you the derivations here. Okay, what is important for you is the formulas and how to apply that formula. So here we have delta U is equals to W plus Q. Right? This is going to be the formula here. Right, everyone? Delta U is equals to W plus Q. We are going to apply this formula. Okay, this is the first formula, that is first law of thermodynamics. Second formula is that work done is equals to minus P dV. Right, this is the formula here. Right, these two formulas we are going to use throughout. Right, okay, yes. Now, next thing that here is, let us do some graphs of isobaric, isochoric, isothermal. Right, okay. Everyone ready for the graphs? Now is your time to give me answer the questions here. This is your time to answer the questions, okay? So isobaric means there is pressure is constant, right? You just need to use one equation here. Just use one equation, that is PV is equals to nRT. When we say pressure is constant, that means volume is not constant, temperature is not constant. That means volume is directly proportional to the temperature here, right? Now here what we will say, the graph between P and V. Okay, the graph between P and V. Yes, graph between P and V is going to be, pressure is going to be constant. Doesn't matter what is the volume, right? Pressure is the constant thing, right? So pressure is going to be constant no matter what. Even if we are changing the volume, pressure is going to be constant here. Right? Okay. Now, pressure is going to be constant even if we are changing the temperature. So, here also that will be parallel to x-axis. Right? Okay. Next is volume and temperature. So, they are directly proportional to each other. Whenever there is directly proportional, that is going to be a straight line. Okay. That is going to be a straight line, increasing line. Okay. Temperature increases, volume increases. Temperature increases, volume increases. Right? Okay. Next thing is isochoric. That means you have volume constant. That is PV is equals to nRT. Volume is constant. That means pressure is not constant. What about N and R? N is the number of moles. Okay, they are constant. R is the gas constant. That is also constant. Okay. We are considering here the number of moles is constant. Right? Okay. So here pressure is directly proportional to the temperature. Everybody in the chat box, do let me know if you say that pressure is directly proportional to the temperature. In that case, what we are going to see, that when we are making a graph between pressure and volume, volume is constant, volume is not changing, okay, and pressure is changing. So whenever the pressure is, okay, volume is not changing, pressure is changing, so it is going to be a line that is parallel to y-axis, right? That is going to be parallel to y-axis, right? Okay, this is how we are going to draw it. Yes, bacha? Yes, everyone? Yes, that is going to be, we are not changing the volume, we are just changing the pressure here. Right? Similarly with pressure and temperature. Pressure and temperature are directly proportional to each other. So this is going to be a straight line here. Okay? This is going to be a straight line here. Next we have is volume and temperature. Everybody, yes, perpendicular to P. Very good. That is not perpendicular to P. That is parallel to P. Okay. Okay, bacha. This is parallel to P. This is not perpendicular to P. Right. This is parallel to the y-axis. Because the volume is constant here. Volume is not changing. Pressure is changing here. Right. Here V and T. What is V and T? Volume is not changing. Volume is constant. Temperature is changing. So this is going to be parallel to x-axis. Right. This is going to be parallel to x-axis. Right? Okay? Very good. Very good. Next that we have is isothermal process. For isothermal process, temperature is going to be constant here, and for that we say PV is equals to nRT, and here temperature, here we say T1 here. This is P, wait, temperature is constant, just wait. Temperature is constant, that means this is P1, this is V1. This means P is inversely proportional to V here. Now everyone, what is going to be the answer? Okay, pressure and volume. Pressure and volume, what are they? They are not directly proportional, they are inversely proportional. When two things are inversely proportional, they have a sign like this, okay? They have a C here. They have a C here, okay? They have a C here, right? Okay, then talking about this pressure, talking about pressure and temperature. If temperature will remain constant and pressure is going to change, this is going to be a straight line parallel to y-axis. Temperature is going to remain constant and volume is going to change here. Again, a straight line parallel to y-axis. Right? Okay? Yes, bacha? Yes. Okay, you have Boyle's law, Charles' law, all these laws. Right? Okay? Yes. From which combined we have the ideal gas equation. Yes, bacha? Yes. Okay. Next that we have is the first law of thermodynamics. Next that we have is the first law of thermodynamics. So first law of thermodynamics is delta U is equals to Q plus W. Right? Okay, this is the first law of thermodynamics. Now let us talk about one by one. One by one. Firstly, we are going to talk about isothermal. Okay? Firstly, we are going to, see this law for isothermal, then isobaric, then isochoric, right? Then adiabatic process, all these processing. Then we are going to see work done for cyclic process, right? Okay, so for isothermal process, delta U is going to be 0. When delta T is 0, whenever delta, there is change in temperature is 0. In that case, delta U is also going to be 0. Change in temperature is 0, internal energy is also 0, right? Always remember this. Yes, now if internal energy is 0, delta U is equals to W plus Q, right? If this is equals to 0, then we say W is equals to minus Q, right? Or you can say Q is equals to minus W, and what is W? W is nothing but minus P delta V, right? Okay, so this is going to be P delta V. Right? This is going to be P delta V. That is what is written here. Okay? Understood? Just apply this rule. Very simple. We know all these things. Do we have to cram this? Nothing to cram here. Then why are you scared of this? Now, from this, how I am drawing these conclusions. Just see this, how I am drawing these conclusions. Here, why I have written that heat given to the system. Because, bacha, as you can see from this, heat is given to the system, okay? It is actually given to the system. I am saying given to the system. It is not, this system is taking the heat, right? It is absorbing the heat. If the system is absorbing the heat only, then the heat is positive, right? Okay, so here the heat is positive. This means heat is given to the system. We are giving the system heat. Okay, so they are going to ask questions, not these questions are not, they are not going to ask these questions. They are going to ask questions from these statements. Okay, that when there is isothermal process, heat is given to the system or heat is taken out from the system. Heat is given to the system. Okay, heat is given to the system because here we see that Q is positive here, right? Q is equals to positive here. Here we say under isothermal condition is used in work done by the system. Now I say second thing is work done by the system. That means work done should be negative here. Is it? Is the work done negative here? Is the work done negative? Yes, the work done is negative here. I have written work is equals to minus PdV. Okay, I've written work is equals to minus PV. Work is done by the system. I'm giving the heat. Just imagine this. You have a container that has gas, right? This is also general, okay? You have gas, right? You're giving the temperature. The molecule are going to go here and there, okay? The kinetic energy is going to increase. That way the motion is going to increase. They're going to expand. Work is done by the system, right? Expansion is happening here. Expansion is happening, okay? This is a case of expansion. You are giving the heat, system is expanding. Right? Okay, so these questions that we are going to conclude here, right? For every single concept, for every single kind of process, right? Next thing is, next we have, that is for adiabatic process. Adiabatic process, that means heat change is going to be 0. There is no heat change in this. That means this Q is going to be 0. Okay, here we can see delta U is equals to W. No, nothing to learn here, just few things. That is this formula, just put the values here, okay? Just put the values here, delta U is equals to W. Now you know internal energy is equals to W, right? So now let us see what we conclude from this, okay? That is delta U is equals to the work done on the system. Now why I have written the work done on the system, right? There is no heat exchange, right? There is no heat exchange in the system and the work done is on the system. Why we are saying the work done on the system, right? Why we are saying this, everybody? Okay, so what happens here when there is adiabatic process? Okay, when there is adiabatic process, everyone, just let me, okay. So U final is greater than U initial, right? In that way, this delta U is going to be positive, right? Delta U is going to be positive here, right? Delta U is going to be positive, right? Okay, this whole thing is going to be positive here. And here, what we are going to write it here, just see this, what will happen. In this case, you have W is equals to minus P dV, right? Okay, you have W is equals to minus P dV, right? So, here P, V minus P initial, right? Okay, we are also going to draw the formulas of work done. In that case, you will be able to understand that why this work done is positive here, right? So what you will observe here, that here this whole term is going to be positive, right? So there will be compression, the whole term is going to be positive here. So hence we are going to write that work done is going to be positive. We are going to do different formulas of work done here, right? For adiabatic, for all these processes, what we are going to see that internal energy is, there is increase in the internal energy. That means internal energy is going to be positive here, and work done is on the system. That means work done is also going to be positive here, right? Okay, understood this? Yes, bacha, understood this? Everyone? Yes. If work done is positive, only then internal energy can be positive, right? So experimentally, what we observe that in case of adiabatic process, this internal energy change is positive. That means this whole value should be positive. That means minus P dV should be positive. So for that to be positive, dV should be negative, right? dV should be negative. That means change in, yes, okay, sure. Ma'am, why W is positive? So see this, bacha. So this was experimenting. We'll also see the formulas for that. I'll teach you that. Just wait a minute. Okay, if you want, I can also write it here. Because adiabatic process have two formulas, right? It has formula for reversible. It has formula for irreversible. We are going to do that, okay? We are going to do the formulas of work done. But now what I can tell you is, for example, work is equals to minus P dV. Because firstly, we have to know what is reversible, irreversible. Then we have to, because adiabatic process has so many things involved in it, right? So why I'm saying this is this, right? Okay, if I'm saying this is positive, this should be positive, for this should be positive, this whole term should be positive. That means dV should be negative here, right? Okay, and not only this formula is used for adiabatic, we are going to convert this formula into something else. and that term is going to be positive, right? Okay, for adiabatic. Yes, okay, for adiabatic, that whole term is going to be positive, right? Just wait for 1 hour and I'll teach you that formula. From that, I'll pick this concept. Okay? Yes? Perfect. Don't worry. I'll teach you that, but right now, just understand this thing. That this whole term, this work should be positive. This should be positive, this should be positive. Right? Work is done on the system. Work is not done by the system. Right? Okay? Work is done on the system for adiabatic process. But I am going to teach you that when we do the adiabatic process formula for reversible and irreversible, then you will have more clarity on that. Right? Okay, next is the cyclic process. Right? Next is the cyclic process. We know that cyclic process, all the state functions are 0. That means delta U is going to be 0. There is no internal energy change. If you say you have delta U is equals to Q plus W, this is going to be 0. Isn't it the same case as isothermal process? Right? So it is same as isothermal. Same as isothermal. Okay? This thing is same as isothermal. We have this concept. Work is done by the system. Okay? Where I have written, wait. Heat is absorbed by the system. Right? And work is done by the system. Right? Work done by the system. Okay? That means heat is going to be positive. Work is going to be negative. Right? This is same as isothermal. Same as isothermal. Because here the concept is same. Delta U was 0 there because delta T was 0. That is why delta U was 0. Here delta U is 0 because state functions are going to be 0 for cyclic process. Right? Okay, but the conditions, the conclusion is going to be same. Right? Okay? Yes. Now, next is for, this is third, this is fourth. That is isochoric. That means when you have volume is equals to 0. There is no change in volume. Now if you say volume is equals to 0, in that case, work done is also equals to 0. Now if you put this thing here, very important formula this one. Okay, you have delta U equals to work done plus this. I am saying this work done is going to be 0. That means delta U is equals to Q. Now why QV? QV means heat energy change at constant volume. So here we have this formula, very important, very important formula. Okay, when we derive heat capacity, we are going to use this formula also, very important formula, that change in heat energy at constant volume is equals to internal energy change. Yes, okay, understood this? Now let us see what is the value of Q and what is the value of work done. Okay, so heat given to the system. Here we can say the work, here what will be the answer? Q is going to be positive. Okay, I'll write it here. Q is going to be positive. Right? Volume increases. Right? Now, what we say here, that in this case, okay, in this case when delta U is going to be 0, in this case we say at constant volume, what happens? There is increase in the internal energy change. That means UF minus U initial is going to be 0. Final energy minus initial energy is going to be 0. That means this whole term is going to be 0 and this term is also going to be 0. That means change in heat energy is going to be positive. The work is done, the heat is absorbed by the system. Right? It is given to the system. Right? Okay? No work is done here. And it means no work is done in isochoric process. No work is done. All the things that I am marking here, okay, all the theoretical points that I am marking here, okay, you must remember that. Heat supplied to the system is stored as internal energy and hence temperature of the system will change here. Now, how we say that temperature of the system is going to change here? As I told you, delta T is directly proportional to delta U, right? If delta U is going to increase, delta T is also going to increase. That means the temperature of the system is also going to change in this case. Right? Okay? Yes. Next thing is, fifth one, same as this one, that is isobaric process. right? For isobaric process, I say pressure is going to be this. Okay, so now see this. Okay, very important concept. Very important concept. See this. You have Q is equals to, you have delta U is equals to Q minus W, Q plus W. Okay, or you can say Q is equals to delta U minus W, right? Q is equals to delta U minus W. Everyone, what is delta U? You can say U final minus U initial, right? Okay, minus, or you can also write it as U2 minus U1. Okay, U2 minus U1, finest minus initial. This is going to be work is minus P delta V. So I will write it here minus P dV, right? Or delta V, you can write both. Okay, delta V, right? Okay, so here I can write, that means V2 minus V1, is it? So this is U2 minus U1, this is minus PV2 plus PV1, right? Again, here U2 minus U1, this is going to be plus PV2 minus PV1, right? And this is going to be U2 plus PV2 minus U1 plus PV1. Now what is this? Now what is this? What is this, bacha? What is this? U plus PV. U plus PV is nothing but this is enthalpy. Okay, so I'll write it here that Q is equals to, that is H2 minus H1. So here we are writing this for constant pressure. Here the pressure is constant, the volume is changing, right? So that means this is QP. Okay, here we are talking about QP, right? So that is QP is going to be equals to delta H, right? So I'll write it here. QP is equals to delta H. What we have concluded from this is QP is equals to this and QV is equals to delta U. Two most important formulas. Okay, very important formulas. QP is equals to enthalpy change. QV is equals to total internal energy change. Yes? Okay, bacha? Yes, any problem here? Any problem here? Any problem? Now, everyone in the chat box, any problem? QP is equals to delta H, QV is equals to delta U. Yes? Okay? Yes. You have to learn the clouds, okay? All the things that are in clouds, okay? This you can skip, okay? This is just for that how this came, okay? What is this conclusion came from, right? That is why I have derived that, but you have to learn all the clouds, okay? All the clouds are important for you. All the clouds in my notes, that you must have a proper notes of your own of that clouds formulas. In physical chemistry, wherever I write this cloud, that is important, right? Okay, bacha? So this is equals to this, okay? Delta H is equals to delta U plus P delta V, okay? This is the formula, right? Okay, understood this? Yes, bacha? Now, next question here, the question here is that is asked is, in a closed insulated container, okay, closed insulated container, a liquid is stirred with a paddle, right, to increase the temperature. We are increasing the temperature, right, okay. Which of the following is true? Closed insulated, that means heat change is going to be 0. The formula that we have is delta U equals to W plus Q, where this is going to be 0. That means we have this formula, right? Which is not equals to 0, but Q is equals to 0. Delta E is also delta U, okay? Internal energy can be denoted by delta E or by delta U, one and the same thing, right? So the answer is going to be A, right? Okay? Okay, sure, I'll use different colors, okay? because our life is already very boring. At least use different colors to make our life little colorful, right? Okay, so now bacha, next we have is reversible process and irreversible process. Now see this, okay? Just using beautiful colors for you. Let me see if I have any beaker. Okay, there are tools maybe. Let us see if there is any beaker or anything. I guess there is a beaker. Okay, let me see. Yay! We have this beaker. Okay, yes. Okay, let us draw this to make things interesting for you. Right? Okay, let us use this beaker. This is the beaker here, right? Okay, let us use one more beaker here. Okay, yes. Now we will take full advantage of this one. Okay, we'll take full advantage of this one. Right? Okay, students. So now let us see. We have two beakers here, right? Okay. See, I have made chemistry already very colorful for you. Right? Chemistry is very colorful. So we have beautiful beakers here. So this process we are going to understand two processes, that is reversible and irreversible process. Now let us understand that. If we talk about reversible process, for example, there is a piston here. Okay, there is a piston here. We are using a piston here, and in this case, you have a piston here. You have a piston here. Okay, here also you have a piston here, you have a piston here. Piston is to increase the pressure. That means to increase the pressure here. That means to increase the pressure here. Right? Okay, this is how you are going to increase the pressure. Right? Okay, so now what is the difference in these two beakers? The difference here is that in one beaker, what I am using here, in one beaker I am using this very solid thing. Okay. I'm using some solid block. I'm using this wooden brick. Okay. In one beaker, I am using this wooden brick here. Okay. In one beaker, I am using this wooden brick here. And in another beaker, I am using sand. Okay. I am using sand here. You have to tell me which one is the reversible and which one is the irreversible process. Right? Okay. Now let us see. I am applying pressure here. One thing I have sand, one thing I have wooden blocks, right? Okay, and I am decreasing the pressure here, right? I am increasing the pressure, I am applying the pressure here. So, what will happen in case of wooden block? When I say, okay, you have to do everything today, you have to do 3 chapters today, you have to do 4 chapters today, what you will feel? You will feel very low, okay? You will feel very heavy, right? This is what they are going to feel. Using a wooden block and applying the pressure here is going to stress this beaker so much that it is going to come at this point and it is not going to reverse back because already you have so much pressure. If you demotivate someone to that extent that they never feel motivated again, this is that thing. Okay, when you demotivate someone to that extent, they feel very low and demotivated, they don't want to study. Right? This is the kind of demotivation that this wooden block is doing. That is why this is called irreversible process. Right? It's like if I tell you that you have to do everything one by one step at a time. You have to do, attend this lecture today and do the PYQs. Tomorrow do the NCERT question, attend the another lecture and do one by one. Okay, I'm not loading you with so many things. That is the sand. Okay, that is the sand. It is applying pressure, then pressure is decreasing. Applying pressure, pressure is decreasing. Applying pressure, pressure is decreasing. It's that one day you will study more, other day you will study less. One day you will study more, other day you will study less. Eventually you are consistently studying. Okay, you are not at that point, okay, I have to do everything in 15 days. Right? You are consistently studying. So this is the case with reversible. And you know this through your life, then whenever we are consistent, right? Here what is happening? Okay, you are applying the pressure, then it is getting like lower, it is getting to this point, then again you are increasing the pressure, this is getting to this point. Again you are applying the pressure, this is getting to this point. Again you are increasing the pressure, this is getting to this point. Again applying the pressure to this point. again increasing the pressure to this point. So this is what we see, we observe here, that when you have reversible process, there are infinite steps, okay? There are infinite steps. But when you have a irreversible process, this is just one step and you fall down, right? There is no reversible thing in that, okay? Right? Okay, that is why consistency is important. Doing things in infinite steps is important. Doing everything in one day will not, do anything, will not do any favor to you, right? So this is an infinite step. This is infinite step. Infinite step. This is big change. This is single big change. This is what I say, a big change that you have done. Just you have studied for, like what I say, you have studied one day so religiously that you crack something. Okay, that is one day study. This is, which is consistent, right? Okay, yes, bacha. This is like when you dip biscuit in a tea for a minute, it will not come back. Wow, wow, what a question. What an example, Sharath, what an example. When you dip a biscuit in the tea, what will do? The biscuit is not going to come back, right? Okay, that is not reversible thing. Right? If you make Maggi, if you are making Maggi, we cannot separate the Maggi. Now we have made the Maggi. That is the irreversible process, right? Okay. So all these are irreversible processes. Now, if I am drinking this water, I cannot just let this water out of my mouth now. This much clean water, not possible, right? Okay. That will be possible by puking only, right? So that is not possible. Irreversible processes they are, right? Okay, yes. So let us see this. These are the reversible processes. A process which is carried out so slowly, very slowly, that the system and surroundings are always in equilibrium during the process. The term is known as irreversible, is very slow and takes infinite time. Okay, very slow, takes infinite time. Okay, if you want to reverse something, right? So if you want to study, like, okay, one day, if you waste one day, that won't matter. What is that? If you are studying for 2 years continuously, even if you don't study for 1 or 2 days, that doesn't matter, because that is a reversible process, right? Okay, and what about irreversible process? Processes other than reversible processes are known as irreversible processes. Complete in finite times. All real processes are irreversible processes, right? What you do in reality, all are irreversible processes. We cannot reverse things in our life. Okay, we cannot undo things in our life, right? So now let us see, this is the work done. Now if I say you are giving the pressure, you are applying the pressure, you are increasing the pressure. This is compression. Okay, in compression you see delta V is going to be negative. That means final volume is going to be less here. Okay, this is the initial volume, this is the final volume is going to be less here. In that case, what we say, work done is on the system, right? Okay, work done is on the system. That means the work done is going to be positive here, right? Work done is by the system, the work done is going to be negative here, right? That is the case for expansion. Work done is by the system, it is going to expand, okay? It is going to expand, right? Okay, yes. Next thing, bacha. Now let us see the work done for reversible and for irreversible processes. Now if we talk about the work done for reversible, this is for reversible process. Okay, for reversible process, we know work done is equals to minus P delta V. Right? If we talk about reversible process, that means I am saying that is in very small, tiny steps. Okay, very small, tiny steps. Right? In that case, what I am going to tell you here, that we are going to use dV, because dV is the very small change. Delta V is a large change as compared to dV. So here we are going to use integration. Okay, here we are going to use integration, that is integration minus P dV. Right? Okay, here we are going to use integration here. Next thing is, that is du. Du is the small change in that work. This is minus P external, the external pressure that we are applying here, dV. Okay, integrating this is differentiation. And what is integration? When we are, in that pattern of time, if I am saying from V1 to V2, okay, I am going to calculate the work done here. For that I have to do the integration, right? Okay, that is the addition of very small steps, right? Okay, so work done here will be integration V1 to V2 P external dV, right? This is the formula here, right? Okay, if you don't want to remember this formula, just remember this formula, that for reversible processes, infinite steps, very small change, so that is dV, and dV always says that you need to integrate that. Okay, now if we talk about, I'll write it here, that they are talking about reversible process here. Okay, this is for reversible process. Now if I am talking about irreversible process, the change in volume is going to not to be d. This is not dV. Okay, we write W is equals to minus P dV. Right, this is for a very small change. If the change is not small, in the case of wooden block, the change was not small. There was an immediate change, right? So that would be delta V here. That is, work done is equals to minus P delta V. Right, okay, bacha? So this is going to be W is equals to minus P delta V. Is this clear to everyone here? Yes, bacha? Minus P delta V. There is no here, wait. Yeah, this is for reversible. I thought this is for irreversible. Irreversible is the next one. Okay, this is for reversible process that I have just taught you. Okay, this is the same thing that I have just taught you. Okay, same thing that I have just taught you. That one thing here is very important, that we say for reversible process P external is equals to P of gas plus change in pressure. Right, there is change in pressure. So in that case, what we say, the change is so little that we ignore this. Okay, so here P external is almost equals to P of gas. The change is very less. So here gas is taken, the pressure of gas is taken here. I'll write it in my own writing here. Okay, so here I'll write P reversible equals to, this is integration, minus P of gas, right? This is dV. This can be initial to final, right? So this is the formula for reversible, right? And what about irreversible? When there is large change. So in that case, we do not use this dV. Okay, instead of dV is the small change. We use W is equals to minus P dV, right? This is for small change. Okay, that will be delta V. Okay, what is delta V? That is simply what I am going to write here, minus P V final minus V initial, right? Okay, this is going to be the answer here. And here, ma'am, what is the pressure? Are we going to use the pressure of gas, or are we going to use the external pressure here? Right? They will give you the external pressure in this case. Why they are going to provide you with the external pressure, anyone? Why external pressure? Why external pressure? This is for irreversible. Irreversible. External pressure is because in this case, external pressure, why external pressure? Because here the change is large, right? Okay, we are actually applying the pressure. We don't need to know what is external pressure, right? That will be equals to the change in pressure and the gas. Right? Okay. Ma'am, that delta V for irreversible. Yes. Okay, this delta is means large. Okay. This is just very small concept, that this D is also changed, delta is also changed. Both represent the changes. Both are representing the changes. But this D is representing the very small change. Very small change. And this is large, not a very large change. I won't say this is a very large change. No. This is also a small change only. But in comparison to this change, this is going to be a large change. In comparison to D, right? Okay? And for D, we always use integration. And here we simply subtract it. Right? Okay? So these are general rules of mathematics, right? Okay, yes. So that is the change, and here if I combine this with thermodynamics, this we are going to use for reversible because there is small change, and this we are going to use for irreversible. Irreversible, right? And that is why here I have W is equals to minus under root PdV, and here I have, or I am going to write it here gas also, right? Okay, P gas dV. I don't want to spoil your notes here, right? This is going to be W is equals to minus P delta V. Okay. Yes, I think this conclusion had made things easy for you, is it? This is P external and this is P gas. Yes, bacha, I think this has made things easy for you, is it? Yes, bacha. And here I'll write one more thing, that this is an infinite step, right? That is why very small change. This is finite step. This is finite step. That is why the change is large here. Yes, bacha, this is the conclusion of everything that we have studied for reversible and irreversible. Yes, understood this? Perfect, perfect. Okay. Now we have calculation of work done here. Now let us see for reversible and irreversible processes, if you have expansion and compression, which is more and which is less, right, from the graphical manner. If we say for expansion this means V final is always going to be more than V initial. In case of compression, V final is going to be less than V initial, right? There is compression and expansion is this one, that volume is going to increase. Compression means volume is going to decrease here, right? Okay, now next thing that we have is the growth. Okay, now the main thing that we need to note here is that in case of expansion, if you have reversible, here always reversible is going to be more as compared to irreversible. Reversible work done, we know that work done is dependent on the path followed. That is a path function, right? Work done is a path function. That is why we are calculating it for reversible and irreversible, right? Understood? That is why we are calculating this for different reversible and irreversible path. For reversible path, in case of expansion, reversible is going to be more as compared to irreversible. If you're going to expand something and you are doing infinite steps, that is going to be more work will be done here. And if we are just expanding this in one go, that is going to be less work as compared to more steps, right? But in case of compression, when we are talking about we are compressing something, in that case we say that irreversible is going to be more. That if we are doing things in just one go, that work, the work required for that, okay, we are compressing something. This is a very general thing, okay? Just imagine this. You have a box. Just imagine this. You have a beaker, right? I like this beaker more. Okay. Which beaker you like? The beaker from the tools or my beaker? I like this beaker more, right? Okay, because I can easily erase this, right? Okay. So here we have molecules of gases in this. Now, I am going to compress this. If I am talking about compression, if I am going to compress this, I am going to apply the pressure. If I am applying the pressure, see, when we are going to compress something, we are doing this in one go. That will take a lot of work, okay? It's very simple. If your goal is very high, okay, compressing is a big thing, okay? You are compressing something, you have to apply work, right? Okay, you have to, apply pressure there, right? In that case, in one go, it is going to be very difficult. In one step, it is going to be, the large amount of work will be required. That is why work of irreversible is more than work of reversible. Work of reversible, right? But in the opposite case, if we are expanding something, we have this and I am going to expand this, bacha. What I am going to do here, I am going to expand this, okay? I am expanding this. In that case, what I am going to say, I am not applying pressure here, okay? I am just leaving it as it is. In in that case, just tell me one thing. You have very simple example. You have a bottle of Coke, right? You are just, one thing that you are doing, you are just opening the bottle, right? And the gas is going to expand. In one go, it is easy. But if you are opening this, then closing this, opening this and closing this, opening, closing. In that way, that is going to take more energy of you, right? So in that case, what we will say, work of reversible is going to be more as compared to work of irreversible. That means in just infinite steps, it is going to take more energy, more work will be required here, right? Okay. Yes, bacha, this session is also going to require thermochemistry. Yes, okay. We have the Josh is high, okay. Everyone show your Josh in the chat box. Yes, everyone. Show your Josh in the chat box. Yes, fire in the chat box. Fire in the chat box. Or green hearts in the chat box. I want to see green chemistry here. Yes. Okay. So, yes, bacha. Any problem till now? Any problem till now? Any problem till now? Is everything clear? Yes. Okay. Okay. Perfect. Perfect. So now, next thing that we have is work in isothermal process. Okay. Now we are going to calculate work in all the processes. And questions are asked from this part of thermodynamics. Okay. So first thing is work done in isothermal process, then isobaric, everything. Now, student will ask that, ma'am, is the derivation of all these important for NEET examination? No, that is not important for NEET examination. No, I am not going to go into the derivations. Okay, you must know what are the formulas and you must know how to, how to apply that formula. If you don't know how to apply that formula, derivation is not going to be in use. Okay, if you don't know the derivation but you know how to apply the formula, so that is going to be more valuable for you. Yes, bacha? Yes, perfect, perfect. So now let us see this. We say that work in isothermal processes, temperature is constant here. That means dT is going to be constant here. Change in temperature is going to be constant here, right? For expansion of ideal gas, we say, what we say see one thing here, that is, this CV, this CV is the heat capacity. Okay, this is the heat capacity, everyone. This is the heat capacity. Okay, this is also the heat capacity. Heat capacity we are going to do. Don't worry. Just firstly see this formula. I'll tell you how this formula came from. Okay, what is this formula? What is the value of this formula? We'll derive this formula. Okay, firstly just see this formula. That for expansion of ideal gas, you know that delta U is equals to NCV delta T. If delta T is equals to 0, that means delta U is also going to be 0. And delta H is also going to be 0. This is what they are saying, that for isothermal process, delta U and delta H are going to be 0 here. Okay, both of these things are going to be 0 here, and this is the curve for isothermal process, and the curve for adiabatic curve. If I say this is the curve for adiabatic curve is going to be steeper than isothermal curve. Right? Okay. Next thing, bacha, that we are going to do here is work in isothermal. What you have to do here is just remember the formulas here. Okay. I have made another. Wait. Let me see if I can. I have made the formulas for you. Okay, just go through this. Okay, then we will go through the formulas. Okay. Just go through this. After that, we will go through the formulas in a very crisp manner. Okay? Yes. So now, you don't need to worry about this derivation because this is a very simple derivation that in case of isothermal process, if you have reversible, we are going to differentiate this. Okay? We are going to do this. We will use dV here and we are going to integrate this. Right? Okay? In that case, P, see, from ideal gas equation, you know this, PV is equals to nRT. Right? Okay? N is constant, R is constant, T is constant, right? P and V In case of isothermal process, P and V are going to change here, right? So same thing, bacha. After applying the values here of V1 and V2 here, first we put P gas, P is equals to nRT by V. Okay, applying the formula here, these three things are constant, right? These things are constant. Applying the formula here and integrating it, that will be log, natural log V2 by V1. Now, what you need to remember here is these two formulas. Okay, these two formulas that work for isothermal process in case of reversible. This will come after. See, this is for reversible, not for irreversible. For reversible, this will come after the integration, and here we are going to use the log. Okay, here we are going to use the log. Okay, in natural log we will not use 2.303. In log base to 10 we will use 2.303, and this will be final. Just remember one thing, in log we have final volume by initial, and we have initial pressure by final pressure. That's it. Here you have V2 by V1, here you have P1 by P2. That is, in volume we have final volume by initial volume. In pressure you have initial pressure by final pressure. Right? Okay, that is the difference here. This is the difference here. Okay, that is the first thing. Now, if we talk about irreversible, this is no, here we are not going to integrate anything. Here we are going to use delta, right? Here we are using delta here, right? Simply use delta here, that is, delta U is 0, yes. Okay, applying the formula delta U in work is equals to, delta U is equals to W plus Q. This is going to be 0, so W is going to be minus Q, right? Apply this formula here, you will get these two equations, right? Now, next thing is work for irreversible. For irreversible work, we are not going to integrate that. We are going to use delta here, okay? Just simply write work is equals to minus P delta V. What is delta V? This is final minus initial, right? This is final minus initial. Now, if you write it here, minus V2 minus V1. Now, ma'am, how we write NR? Okay, this is from ideal gas equation. This is from ideal gas equation. So, what you are going to write it here? Minus P nRT, and this is going to be 1 by P. This is volume, right? So, this is going to be pressure here, right? So, this is going to be P2 minus 1 by P1. Okay, this is going to be the answer. Right? Okay, just one thing you need to remember, that is this one. One thing that you need to remember is this one. Okay, this one. That's it. Okay, if you know this thing, this answer is going to be very easy for you. Right? You don't need to cram it. Right? Okay, if you know this concept. Now, next is for isochoric. For isochoric, everyone, we know that dV is equals to 0. If dV is equals to 0, W is equals to minus P dV. This is also going to be 0 here. So from first law, we can say that delta U is equals to QV. Right? Okay? Delta U is equals to QV. We have derived this, right? We have derived this. Now, next is bacha. Next is for isochoric. We have, see, for isobaric, we have, this is, first is isothermal, second is isochoric, third is isobaric. So for isobaric, we know that the pressure here is constant, right? The change in pressure is going to be constant. Here we are going to talk about just reversible, right? Only reversible process here. So when we are going to talk about reversible process here, W is equals to minus P external dV, because we are talking about the reversible process here, right? So integrating it, you will have this value. Integrating it, you will have this value, right? By integrating this, now we had this value. But in case of, but just see this. Where we have this one, okay? So see, in this case, here we have P dV. Okay, here we do not say that pressure is constant here. That is why I have applied the value of PV is equals to nRT. I have applied this value here because I am saying that, see, from this equation only we are deriving two different formulas. For isothermal, I am integrating this one. Okay, I am converting this pressure into volume and then I am integrating it. Yes, I am converting this because this pressure is not constant. That is the difference. Okay, here the pressure is not constant. That is why I have taken out the value of pressure from the ideal gas equation. Then I put the value here where nRT is constant, and now I have the value that is integrating 1 by V dV is equals to natural log V, right? Okay, but in this case, this pressure is constant. This is constant. So this will be taken out of integration because this value is constant here. This will be taken out of integration, and integration of 1 dot dV is equals to V. Okay, integration of 1 dot dV, right? Okay, bacha. I think we are almost maybe 1 hour more, right? Okay, I think by 9 o'clock we will complete this session. Yes. Okay, so this is dV. This is V. So here we have V. This is final minus initial. This is the work done for isobaric process. Next is cyclic process. See, for cyclic process, work done is equals to area covered. Okay, work done is equals to area covered. Right. Next is for clockwise, it is going to be positive. For anti-clockwise, it is going to be negative. Okay, bacha? Yes, understood this? Any problem till now? Yes, bacha? Wait. Written the opposite here. Clockwise it is negative. This is positive. Right? See here in cyclic process, all the state functions are going to be 0. That is delta U, delta H, all these state functions are going to be 0. If this is 0, QV is going to be 0. If this is 0, QP is going to be 0. Right? Okay? Yes? Understood? Now, next is the question. If X moles of ideal gas at 27 degree expands isothermally and reversibly from volume of this and this. See, they are talking about the isothermal process. Okay, now they are talking about reversible or irreversible. X mole of ideal gas, this reversibly. Okay, reversibly, everybody. Reversible means integration formula. That means log formula. Okay, so work done is going to be here. They are using natural log. So I'll use minus. You have natural log. You have nRT natural log finals. They are talking about the volume, right? They are talking about the volume. This is actually final minus by initial, right? If they talk about the pressure here, I will write initial by final. This is for pressure. This is for volume. For volume, I write here final by initial, final volume by initial volume. Right? Okay, just put the values here. They are saying the volume is increasing y to this. This is the final. This is the initial. This is the initial. And what are the number of moles? Number of moles are x moles. Okay, this is the moles. Okay, so write it here. This is minus x, and this is going to be final is 10 by, and this is y. So this is going to be minus xRT. Temperature here is, okay, temperature here is 300 Kelvin, okay, 300 Kelvin, so just put it here, minus 300 XR, okay, so minus 300 XR, natural log of 10, this is the answer, okay, y, after cutting the y, we have 10, right, okay, bacha, yes, okay, now next question here is, a gas is allowed, okay, NEET 2017 question, a gas is allowed to expand in a well-insulated container against a constant external pressure. That means they are talking about isobaric, okay, they are talking about isobaric process. Isobaric process, so gas is allowed to expand, that means volume is increasing, right? In a well-insulated container, that means Q is equals to 0. Q is equals to 0, right? Of this pressure from an initial volume of this to this. This is the external pressure, this is P external, and this is volume, right? This is the change in volume, the change in the internal energy. So see, delta U is equals to W plus Q. Here we have Q is equals to 0, right? Heat change is equals to 0. In that case, we can write here, delta U is equals to W plus Q, where Q is equals to 0. So we can write delta U is equals to W. And what is the value of W for isobaric process? That was, what was that? See, simply if you don't remember this, very simple. In that case, pressure is constant. Okay, so that will be, we are talking about reversible process only, right? So that is, pressure is out of the integration. This is dV. Okay, what is the value for this? This is V. Okay, this is initial, this is final. So this will be final minus initial, right? Okay, this will be final minus initial, right? So just apply the values here. Delta U is going to be minus P. Pressure here is, bacha, pressure here is 2.5. Pressure here is 2.5. And volume, final volume, this to this. Wait. From this to final volume 4.5, and this is 2.5. This is 4.5. This is 4.5 minus 2.5. Right? So just this is 2 into this is minus 5. How this is negative? External pressure of this from an initial volume of this to a final volume of this, the change in internal energy in joules is going to be. So let us see the internal energy change in joules, okay? Internal energy change in joules, okay? Here we have in liter, this is not in joules, okay? This is not in joules. We have to multiply this with 101.8 something, right? To convert it into joules, right? So that will be around 505 something. So I guess 505, this should be the answer, right? B should be the correct answer. Let us see. Yes, B is the correct answer. So, okay, just multiply. This is 3, okay? 3 to 5, okay? This is 3 to 5. Multiply this by 3 to 5 to convert it into joules. Otherwise, it is in liter atmosphere, right? Okay, this is in liter atmosphere. Right, so convert it into joules and multiply this by 101.3. Right, you will get the value 506 negative value, and this is going to be your internal energy. Yes, bacha. Okay. Yes, very good evening, beta. Very good evening. Next thing that we are going to do here is heat capacity. So for heat capacity, firstly let us see what is the heat capacity. It is the heat required to change heat required to raise the temperature by 1 degree Celsius, right? To raise the temperature by 1 degree Celsius. Now very simple thing, how to do the formulas, ma'am, how to write the formulas here, right? So very simple, you will be able to learn all the formulas here. See, this is the symbol for heat capacity, right? This is the symbol for heat capacity. Heat capacity is equals to heat required to raise the temperature by 1 degree Celsius. That means the change in temperature should be 1 degree Celsius. So here we are writing it here, the change in temperature. I'll write Q by delta T. This is the heat capacity, right? Okay, so now if we talk about heat capacity at molar heat capacity, that is 1 mole. That is represented by Cm. Okay, so that is going to be Q by delta T. We are talking about 1 mole. Molar heat capacity is for 1 mole. Here I am going to write N here. Okay, so that will be N delta T. Now, if we talk about specific heat capacity, what is that? That is the heat capacity. Specific heat capacity is for Q by M delta T. What is M delta T? M is nothing but this is the mass. specific heat capacity, we calculate it for 1 kilogram. Okay, here we calculate it for 1 mole. So that is why I have divided this by N. I have divided this thing by M. Okay, here we are calculating it for N, 1 number of mole. Here we are calculating it for what? Here we are calculating 1 kilogram. So divided by mass. Okay, so now let us see at constant pressure. If you see at constant pressure, right, this is going to be Q by, this is going to be QP by delta T. Now pressure is not multiplied here, right? Pressure is not multiplied here. Pressure is just that at constant pressure, that is QP. Heat energy change at constant pressure represented by QP. Okay, so I can also write it here, CP equals to QP divided by delta T. Now bacha, QP, everyone here, what is the value of QP? Yes bacha, what is the value of QP? QP is equals to delta H by delta T, right? Okay, that is equals to delta H by delta T. Now bacha, next is molar heat capacity at constant pressure. That is equals to, right, that is equals to QP by N delta T. Now, what is usually written in books and in your NCERT as well, that is written Cp is equals to Q by N delta T. Right? So, what student assume that they are talking about heat capacity at constant pressure. But you know what? Side by they have written for 1 mole. For 1 mole. Right? For 1 mole. This means they are talking about molar heat capacity. Okay? So do not do this mistake. Never ever do this mistake. Always see, they can also mention this symbol, they can also mention this symbol. Just see that are they talking about n number of moles or they are talking about just 1 mole. If they are talking about n number of moles, answer will be this. If they are talking about 1 mole, answer is going to be this. Okay? Yes? So you must have seen this particular formula, right? You must have seen this particular formula, right? Yes? Yes, bacho. You must have seen this formula that we have also written this formula that delta H is equals to N Cp delta T. Remember that? This formula is very famous. This formula is very famous. I'll write it here. Delta H is equals to Ncp delta T. This is for 1 mole. For 1 mole. Right? You can also write it delta H is equals to Ncp m delta T. Okay? This also means for 1 mole. Yes, bacha? Okay. Understanding? Right? Are you able to understand now? Okay, so this is molar heat capacity at constant, this is specific heat capacity at constant pressure. This is going to be QP divided by mass into delta T. Or you can say delta H divided by mass delta T. Right? Okay? Physics as well, perfect, perfect. You have learned this in physics as well, then very good. Now what is CV? CV is equals to QV, constant volume delta T. Right? We can also write delta U by delta T. Right? If we talk about CM at constant volume, this is going to be QV by N delta T. Or you can also write it here. Delta U by N delta T, right? If we talk about specific heat capacity at constant volume, that is QV divided by M delta T. We can write it here, delta U is equals to M delta T, right? Okay. Now, can I write here one more thing? That is, let's make your life little colorful. That is delta U equals to NCV delta T. Okay, this equation is very famous. Now this is for 1 mole. This is for 1 mole. If they write 1 mole, then you should write this. Otherwise, if you do not write 1 mole, you will write delta is equals to NCVM. That means molar heat capacity for 1 mole you are saying. Right? Okay. Understood? Any problem, bacha? Till now, any problem? Are you able to recall all the formulas? Because here we see so many confusions. Usually students get confused in this, okay? They don't know that here we are using molar heat capacity because they are mentioning 1 mole, right? They think this as the heat capacity is constant pressure. This is molar heat capacity. This is molar heat capacity. Okay? Yes. Now, let us do one more formula. See this one. Okay? We have done everything here. Now, next is the relation. Next is the relation that is Cp minus Cv is equals to R. Is this the correct relation? Have I written it right? Have I written it right or wrong? This is wrong. Okay? Why? Because I have not mentioned 1 mole. In your NCERT, they have mentioned 1 mole. Right? If I do not mention 1 mole, I'll write NR. Okay? I'll write NR. If I mention 1 mole, in that case I'll write, if I mention 1 mole, in that case is Cp minus Cv is equals to R. I'll write for 1 mole. For 1 mole. Both of these statements are correct. Okay? Now both are correct. Now both of these statements are correct. But students, what they think, what they do, they apply this thing here. What they do here, the biggest mistake that they do is, if they have not written for 1 mole, you have to multiply this by number of moles. If they have written 1 mole, then you will use this formula. Okay? Yes, very good. Now, next is Poisson's ratio. So now this is the gamma. What is the value of gamma? This is Cp by Cv. This is the value of gamma. This may be adiabatic index, heat capacity ratio, adiabatic exponent or eccentric exponent. Okay, so many names of this. Now, after applying this thing, okay, what you will get? Cp is equals to gamma Cv. Okay, and then you will get this formula. See, these are the two formulas in case of gamma. What is gamma? Gamma is Cp by Cv. If you have to calculate Cv value in terms of gamma, if they have given you gamma, right? Now, ma'am, how do we calculate gamma? Right? First, you just see these formula. This is Cp by Cv is equals to gamma. Cv is equals to R by gamma minus 1 and Cp is equals to gamma R by gamma minus 1. Very simple formula. Right? Now, ma'am, how do we calculate? Right? So, now let us see the gases, the kind of gases. They will give you monatomic, diatomic, triatomic gas, and then you have to calculate Cp, Cv, gamma, degree of freedom and all that. Okay, so now let us see that. One thing is that for a monatomic gas, if there is just one atom, see you have 3 axes, this way, this way, this way, x, y and z. You have 3 axes, so it can rotate, it can have translation motion here, right? X axis, y axis or z axis. These are perpendicular to each other, right? This is the first thing. Now, that means it has 3 motions, that is 3 translation motions. So, the degree of freedom is going to be 3. So, the degree of freedom is going to be 3 here, right? The degree of freedom is going to be 3 here. Now, after that, okay, if you know the degree of freedom, you will be able to calculate everything here, right? Just calculate gamma and then you will be able to calculate everything, right? Okay, bacha. So, now let's see this. Done this whole table for physics. Okay, then you can repeat. Yes. Okay. So then diatomic and linear. Diatomic means if you have 2 molecules, okay, or you have a triatomic molecule, but that is linear, like carbon dioxide, right? Okay, but that is linear, right? Not non-linear. So for a linear molecule having more than 2 atoms, 2 or 3, in that case you will have 3 translation. Here we have x-axis, y-axis, z-axis. You have 3 translation motions, right? You will have 3 translation motions. And And what about the rotation motion? A single atom cannot rotate itself, right? But if we talk about this one, wait. Yes. So if we talk about the rotational motion, see this. You have this, for example, any diatomic molecule, right? So how it is going to rotate? Either it can rotate like this. Okay, it is not translating. It is not going here and there. Translating is going somewhere. Either it can rotate like this or it can rotate like this. Okay, either it can rotate like this or it can rotate like this. There are two ways of rotation, like this or like this, right? So it will have two rotational motions and coming to 5 degrees of freedom. Okay, the degree of freedom is going to be 5 here. Yes, bacha. So next is non-linear polyatomic. Let us calculate the degree of freedom here. So in this case, what we are going to have, for example, water. For example, water. That this is non-linear. This is non-linear. This is a non-linear molecule. In that case, for example, you have this one. Okay, this is a non-linear molecule. In this case, it will have 3 degrees. It will have 3 translation motion: x-axis, y-axis, z-axis. Okay, so write it here that it will have 3 translation motions, right? And what about the rotation motion? What about the rotation motion? So here, what kind of rotation motion it is going to have? It is going to rotate like this. It is going to rotate like this. Yes, it is going to rotate like this. Yes, it is going to rotate like this. Second rotation motion. Okay, first is it is going to rotate like this. Okay, up, down, right? And second thing is it is going to rotate one thing here, one thing here. Okay, or you can say simply this way. I know if I am able to just, I think this pen is much better. This is, it is going to rotate like this. Okay, rotate like this. One thing here, one thing here. 1, 2, 3, 4. Right? So these are the rotation motion. What is the third rotational motion? Okay, that is this one. Okay, that is this one. Wait, this one. Okay, this is the third rotational motion. Either it can rotate like this. Okay, so these are the kind of rotation motion that it is showing. So it will have 3 rotational motion. It will have 3 translation motion, contributing to total 6 degrees of freedom. Okay, they will ask you just these 3 cases. So in that case, what is the value of gamma? What is the value of gamma and what is the value of phi? Okay, Cp minus Cv is equals to R, that you can calculate. Right? What is the value of gamma? Everyone here, what is the value of gamma? 1 plus 2 by degrees of freedom. This is R by F. Wait. R by RF by 2. Okay. RF by 2. Yes. Okay. You just need to remember these 2 things. Okay. You just need to remember this formula. Gamma is equals to 1 plus 2 by degree of freedom. Cv is equals to Rf by 2. That's it. Okay. These 2 formulas. Yes, bacha? Okay. So just apply this thing here. Cv is equals to 3 by 2 R. Right? Diatomic gases, you have 5 degree of freedom, 5 by 2 R. Okay. Non-linear molecule, you have 6 by 2 R. That is going to be 3 by R. Right? And for Cp, you have Cp minus Cv is equals to R. That means Cp is equals to Cv plus R. Right? Just add 1 R here, 5 by 2, 7 by 2, and this is 4 R. Right? What is the value of gamma? That is Cp by Cv, or you can just calculate directly 1 plus 2 by F. Right? Okay. Also, always remember this thing, that the value of gamma for monatomic, diatomic and triatomic. This is triatomic linear, this is non-linear triatomic. Right? Okay? Yes, bacha. Now, answer this question. Everyone answer this question. Okay, answer this question. Okay, so equal volume of two monatomic gases. You have two monatomic gases A and B at same temperature, right? You have equal volume and pressure are mixed. Okay, the ratio of specific and this, they are talking about gamma. They are talking about gamma for this. Okay, you have to calculate the value of gamma for this, right? They are talking about monatomic gases. For monatomic gases, what is the value of gamma, Diksha? What is the value of gamma? That is 1.66. Okay, so the answer is going to be 1.67. Okay, this is a simple answer, that is 1.67. You can also calculate it here. Okay, we have just calculated it, right? That comes out to be 1.66. Next that we have is adiabatic processes. Now Vicha, let us do this. Okay, so for adiabatic processes, as we know, there is no heat exchange, right? There is no heat exchange between system and surroundings. There is no heat exchange. Q is equals to 0. Heat energy is equals to 0. Okay, there is no heat exchange. This is equals to 0. Delta U is equals to W, right? This is the case. Now, they are saying here two things are possible, right? Two things are possible. If W is negative in this case, if W say is negative in this case, then we say, see this, if W we say is negative in this case, in that case delta U is going to be negative, right? In that case you can say delta T is also going to be negative. That means T2 is less than T1. Okay, delta T, that is final temperature is going to be less than this. Temperature is going to decrease here, cooling occurs in this case. But if we say delta U is positive, right? If we say delta, that is the usual case for adiabatic processes, right? If U is positive, in that case delta U is greater than 0. That means delta T is also greater than 0. In that case, final temperature is more than initial temperature. We say temperature increases, heating occurs in this case because temperature is getting increased, right? Temperature increases, this is going to do expansion. Okay, so now let us see the work done for adiabatic processes, right? If Q is equals to 0, in that case W is equals to change in internal energy. What is the formula for change in internal energy, everyone? What is the formula for change in internal energy? We have just done that in case of heat capacity. That is NCV delta T, right? That was NCV delta T. Right, so NCV delta T, and here we will write W is equals to NR. Okay, now this is, what is this CV? What is the value of CV? This is nothing but R by gamma minus 1. That is what I was telling you, that in this case, always remember for adiabatic processes, for reversible and irreversible. See, I will teach you with my own formulas here, right? Okay, wait, just go through this. Just go through this, that will be much easy for you, right? That will be much easy for you. Isothermal reversible, just revise this with me. Isothermal reversible processes, you have W is equals to minus nRT and V2 by V1, P1 by P2. Okay, 2 is for final, and 1 is for initial. 1 is for initial. Right, and here delta U is going to be 0 because temperature change is 0, and delta H is also going to be 0 in this case because temperature change is going to be 0. So applying the first law of thermodynamics, that is delta U is equals to W plus Q, right? This is 0, so Q is equals to minus W, right? Okay, so these are the important formulas from isothermal reversible. For isothermal irreversible, we know that we do not use D here. Okay, we use delta here. So V2 minus V1, and in this case you will use V2 will be nRT by P2. This will be nRT by P1, and here delta U is 0, delta H is 0. Same we have Q is equals to minus W. Right. Next we have adiabatic reversible processes. In this case, heat change is going to be 0, and we have W is equals to nR delta T gamma minus 1. Now how we calculated this? You know that, right? It was NCV delta T, and CV is equals to R by 1 minus gamma delta T, right? Okay, now very important step here. For adiabatic processes, the formula for reversible and for irreversible and for irreversible is exactly the same. The formula is exactly the same, but the method of calculating the temperature is different. Okay, here the formula is nR delta T by gamma minus 1, and here we know that Q is equals to 0. So in first law of equation you have delta U is equals to W, because this is going to be 0. This is going to be 0. Okay, so first law of the thermodynamics becomes this. Now we know that delta U is equals to QV, and QV is equals to NCVM delta T, and QP is equals to NCPM delta T. These are the value of delta U and delta H in case of adiabatic processes. Okay, we have just applied this formula here, right? Nothing is constant here. Okay, nothing is constant here, right? Okay, now next thing is, how do you calculate temperature in case of reversible adiabatic process? In case of reversible adiabatic process, you calculate the temperature using these formulas. Okay, using these formulas. You will be given, you will take the ratio and you will calculate the value of gamma. Right? For example, they gave you the ratio of these volumes. Okay, they gave you monatomic, diatomic, whatever gas they gave you. Right? You calculate the value of gamma. Right? Then you know the value of volume. Then you calculate the value of temperature. What do you do here? That T2 by T1 equals to V1 by V2. Right? Gamma minus 1. Put the value of gamma, volumes, and the temperature. This is how you will get the value of temperature in case of reversible processes, right? But in case of irreversible process, this is the case of irreversible process. This is the case of irreversible process. For irreversible, calculating temperature for adiabatic. Calculating temperature. So you must know which formula to use where. Right? This is your irreversible process, and here how you will do the temperature, how you will calculate the temperature here. This is the temperature that you are going to calculate in this case. Okay? Everything else will be provided to you. You just need to put the values and calculate the temperature. This delta T will be calculated here, and this delta T that you are going to use in this case. Okay? This delta T you are going to put here. Right, bacha? These things will be provided to you. Then you have temperature, there you have pressure P2, temperature T2, pressure is P1, P external is this much. Now calculate delta T. Right? Just put the value of NCVM delta T here. Okay, just put the value of NCVM delta T. Right? Understood? Any problem till now? Any problem? This was the very good evening, bacha. Very good evening. Very good evening. Any problem till now? Any issue, any problem, batao. Tell me, bacha, any problem? Now, for cyclic process, we know that work done is equals to area enclosed. That is delta U is equals to 0, delta H is equals to 0, Q is equals to minus W. Right? For clockwise, it is going to be negative. For anti-clockwise, it is going to be always positive here. For isochoric process, when volume is constant, there is no work done is going to be 0 in this case. Now, here, we know that Q is equals to QV. Okay, QV is going to be delta U, right? So that is NCVM delta T. In case of QP, now see, this is very important in this case. If they ask you, this is isochoric, right? This is isobaric. See this, very important. If they ask you heat capacity, total heat change in case of isochoric, that will be equals to QV. But if they ask you total heat change in case of isobaric, when the pressure is constant, in that case Q is equals to QP. Right? That is the change, heat energy change. Right? In case of when we have constant pressure. Right? Okay? Yes? Now this is important. When they ask you total heat energy change in case of isobaric, that is equals to QP. And when they ask you total heat energy change in case of constant volume, that is equals to QB. Right? Okay. So that this is the same formula. Delta U is equals to NCVM delta T, NCPM delta T. Right? Now, next is isobaric. This is external, V2 minus V1. This is volume. this volume is equals to from ideal gas equation, that will be equals to nRT by P2 minus nRT by P1. Okay, bacha. Any problem? Any problem till now? Any problem? Right, we are almost completing this. Right, free expansion is what? When we have pressure external 0, that means work done is going to be 0. Here heat energy is also 0. So that is why internal energy change is also 0. We say all the terms of first law. All the terms of first law is going to be 0. Okay, all the terms of first law in free expansion is going to be 0 here. Right? Okay. Next, bacha, let us do the state functions now. That is enthalpy, Gibbs free energy, and next is entropy. Right, bacho? Let us do that. Are you all ready for that? Yes, bacha. Are you all ready for that? Yes. So now what is enthalpy? Enthalpy is nothing but this is the total heat content of the system. The total heat content that is called enthalpy, and we calculate the change in enthalpy, representation of internal energy at constant pressure, is equals to Qp minus. Now this is the representation of internal energy at constant pressure, that is equals to delta U. Delta U is equals to Qp minus P delta V. What does this mean? This means delta U is equals to delta H minus P delta V. Because Qp is equals to delta H, right? Qp is equals to delta H here, right? You just need to remember this formula. Very important formula. Very, very important formula, right? Okay. See how this came. This is the first law of thermodynamics. This is first law of thermodynamics. That is internal energy change is equals to Qp, that is constant pressure, minus P delta V, that is the work done. Okay, this is the heat change, this is the work done. Right? Then Qp is equals to delta H. We know that just apply this formula, you will get delta U is equals to delta H minus P delta V. And you know what? Which formula is more famous here? What I will highly advise you to revise these two formulas. You have to remember these two formulas. That is delta U. Everyone, delta U is equals to delta U equals to delta H minus P, or you can write it here delta P V. Now why, ma'am, you have written this? Because if they have not mentioned that pressure is constant, you will apply that formula only. So always clearly see the question whether they have mentioned that pressure is constant or not. So always remember this formula. If they say pressure is constant, this will be converted to minus P delta V. If they say volume is constant, this will be converted into V delta P. Right? So it depends on which is constant here. Right? Next we have delta U is equals to delta H, right, minus NR, P is equals to NRT, NR delta T. Right? Okay, so always remember these two formulas. Yes, bacha? Okay. Now we have, wait. See, Q is the path function. See this, very important that we have. Q is the path function. We know that depends on the path, right? Okay, H is a state function, right? This does not depend on the path, right? Because it depends on internal energy, right? Then P and V are state functions. These are the state functions. Now, they are saying delta H is independent of the path. It does not depend on the path. This is equals to final minus initial. So hence Qp is also independent of the path. That means we say Qp is also independent of the path. So hence at constant pressure what we write, that delta H is equals to delta U plus P delta V. Okay. So just convert this formula here. Okay. You can just convert this formula. Okay. I'm going to convert this formula now. Okay, just because of that minus, what I'm going to, or you can learn that formula also. Okay, I'll just write it here. Okay, you can convert this formula in terms of delta H. Okay, in terms of delta H. You can remember because it's just the differences in the writing. Okay, here I am writing delta H and this is going here. I'll write delta U. So I'm writing delta U plus delta PV, right? And here I am writing delta H is equals to delta U plus NR delta T. Okay, both are same formulas. Anything that you can write. Okay, anything, because I know that student will get confused here, so you can learn any formula here. Okay, yes, okay. So ma'am, when to use this formula, when to use this formula? When you are given pressure and volume, you must use this formula. When you are given a reaction, in that case you will use this formula. When you are given a reaction, you will calculate the delta Ng. Delta Ng, okay, just also one thing. This is RT delta Ng. Okay, so what is this delta Ng? What is this delta Ng? This is RT delta Ng. What is this delta Ng, bachcho? What is this delta Ng? These are the number of moles of product minus number of moles of reactants. Okay, so always subtract the number of moles of gaseous products and reactants. Okay, so this is used when you are given a reaction. This is used when you are given simple pressure and volume. Okay, yes. Now I think this is also done. Now we know that when there is exothermic process delta H is negative, endothermic process delta H is always positive, right? Okay, then we have the difference between delta H and delta U significant when change in volume is significant. They are saying this thing should be significant. This is not significant, this is very small. In that case, this is going to be equal, right? Okay, these two things are change in volume is significant in gases, and that is only possible in gases. So that is why we calculate the number of moles of only gases. That is why I have written delta Ng. Okay, G means only gases. Okay, yes. Next thing here is consider a reaction. If you have a reaction, you are going to calculate. Okay, just simply what I have written for you. Just apply this formula when you have a reaction. Okay, whenever you have a reaction, apply this formula. When you have pressure or volume, you can apply this formula. Here also, if you want to, be more cautious, then apply delta PV. Okay, yes, perfect. Now, next is this question. Okay, this is the question. This is what I was talking about. See what things are given to you. They have given for a reaction this plus this is equals to this at constant temperature. Delta H is equal delta H minus delta U is this. Okay. So here what we are going to see. Okay. Delta H minus delta U equals to RT delta Ng. Okay. RT delta Ng. And what is delta Ng? This is liquid. We are not going to take the moles. This is gaseous. This is gaseous. This is gaseous. So this is 3 minus product minus reactants. 3 minus 6, that is minus 3. So this is going to be minus 3 RT. Right? So answer is going to be B here. Okay? Yes. Done. Next we have limitations of first law of thermodynamics. Okay, what are the limitations? It does not provide information of direction of heat flow. Right? No direction was mentioned here. We just know there is heat flow. What is the direction? It is not mentioned. Heat is unidirectional, moves from hotter region to cooler region. Right? They say that heat is unidirectional. Right? Next thing is here. Certain naturally occurring reactions happen spontaneously and unidirectionally. Now, certain natural processes spontaneously mean they are occurring by its own, right, and unidirectionally. So it does not give any justification for that. Okay, so these are the drawbacks of first law of thermodynamics. Next that we have here is spontaneous process. What is spontaneous process? When the process is taking, it is happening by its own, right? That is called spontaneous process. It does not need any external thing. right? It is happening by its own. Okay, the reaction happening on its own with or without any trigger. That is called spontaneous reaction. And for this, always remember delta G is going to be negative, right? Always delta G is going to be negative here, right? Okay. Next, bacha, we have non-spontaneous process that need any external thing, right? That way only that is possible for that reaction to occur, right? So process which is neither take place by itself nor by any initiation. It needs some trigger. That is called non-spontaneous process, and delta G is going to be positive here, always. Okay. Next, bacha, let us talk about entropy. What is entropy? This is nothing but disorderness. Okay, if there is disorderness. For example, I say I increase the temperature. Then what is increasing? The movement of molecule is increasing, right? Okay, so if I am increasing the temperature, bacha, if I am increasing the temperature, what is going to change, right? If I am increasing the temperature, what about the entropy? The molecules are moving here and there, right? The energy is increasing, right? So entropy is increasing, right? Okay, yes. So now let us see this. Now this is entropy is a measure of randomness or disorder of the temperature, the disorder of the system, and the formula here is delta S is equals to Q reversible by temperature, right? Okay, it is a state function and these are the units, right? Next thing, bacha. Wait. Okay. So now let us see the entropy for different formulas of entropy. Right. Okay. This should be V. Okay, this should be V. This should be Vm. This should be Vm here. Right. So I am writing it here. This should be Vm. Okay. Now, let us see this. So, if you want to calculate for different processes, if we talk about the adiabatic process, for the reversible and irreversible process, always remember these two formulas, because by using these two formulas, you will be able to recall every formula. You will be able to recall all the formulas of thermodynamics. So, now you have delta S is equals to NCV. When you have CV, this will be V2 by V1. When you have CP, this will be P1 by P2. Right? Okay. What is this? This is the formula for work done, right? This is NR, natural log V2 by V1, NR, natural log P1 by P2. And what is this? This is NCV, natural log T2 by T1, and CP, natural log T2 by T1. Right? Okay, when you have V, then you have V2 by V1. When you have P, you have P1 by P2. That's it. Okay. Now, if you know this thing, for reversible process, we know the formula for entropy is equals to delta S is equals to Q reversible by T. For reversible, for adiabatic, see, always what students think that, usually what students think that, ma'am, this is the entropy, right? Ma'am, this is the entropy. You are saying that Q is 0 in adiabatic. So how come we have formula for delta S for irreversible? Because bacha, here I have written Q reversible, not irreversible, right? So here what I will write, that for reversible, Q reversible is 0, that's why change in entropy is going to be 0 here, right? Next we have for isobaric. For isobaric, put the value here. We know for isobaric, we know that for isobaric, this is going to be 0, right? This is natural log 1. This term is going to be 0. This whole term is going to be 0. Why? Because this is going to be natural log of 1, which is 0. Right? This whole term is going to be 0. So this is going to be NCPM natural log T2 by T1. NCPM natural log T2 by T1. For isochoric, you know that natural log V2 by V1 is going to be 0. Here natural log P1 by P2 is going to be 0. Right? So here I can also write it in good manner. So I'll write it here. Natural log P1 by P2 is going to be 0. Here natural log V2 by V1 is going to be 0. So putting the value here, what you will get, NCVM natural log T2 by T1. Right? So this is going to be the answer. For isothermal, you know that all these values are going to be 0. This thing is going to be 0, right? Right? So this thing is going to be 0 here. Wait, this thing is 0, this thing is 0. So in that case, what you will have here, natural log T2 by T1 is going to be 0. Because delta T is going to be 0. So in that case, delta S can be NR natural log V2 by V1 or NR natural log P1 by P2. Right? Okay. So simple formula. You just need to remember this one formula and you can answer all the formulas to that. Okay. Just remember this one formula. Yes, bacha? Okay. Simple. Simple everyone. Simple, right? Okay. Now let us see entropy for different things. Entropy depends on the solid, right? We say solid have least entropy, right? There is like molecules are very close to each other. They are not vibrating that much. That is why it has less entropy than liquid. Then we have gases are maximum entropy. At constant volume, as temperature increases, temperature is increasing, randomness is increasing, right? So entropy is increasing. So simply write it here. If we increase the temperature, entropy increases. If we decrease the pressure, entropy increases, right? If I'm, compressing something, if I'm decreasing the pressure, okay. So if I'm compressing something, right, I am increasing the pressure, right? The molecules are going to be less ordered. They are going to be more in order, right? They will be like, if I'm converting gas into solid, I'm compressing it, no? So the entropy is going to decrease in that way. If I'm decreasing the pressure, I'm expanding the gas, entropy is going to increase that way, right? Okay. So as volume of gases, entropy increases. So they're saying if you say at constant pressure, volume of gases increases. If volume is increasing, everybody, if volume is increasing, entropy is also going to increase here, right? Because we are increasing the volume in that case. So entropy is going to increase here. Next is for gaseous substances, more complexity in the substance, more bonds, more molar mass leads to more entropy. We are saying more complexity, more molar mass, and more is the entropy in this case. Okay. Now let us also learn few examples. Everyone, try to answer this. If I give you one example, that formation of precipitates. Everyone, formation of precipitates. Tell me. Formation of precipitates, denaturation, then you have dissolution, right? Or you have right, mixing, rusting of iron, in which case entropy increases and in which case entropy decreases. Crystallization also, right? Crystallization, precipitation, in these cases entropy is going to decrease, right? Because they are going to get converted into solid form. Denaturation, dissolution, mixing, rusting, all these things, entropy is going to increase here, right? Okay everyone? Yes beta? Thank you beta, thank you. Okay ji? Okay, understood. Any problem till now? Next is entropy. Now you have, as the number of gas molecule increases during chemical reaction, entropy increases. Number of gas molecule increases, they are saying. Okay, so if I have number of gas molecules that are increasing during a chemical reaction, if the gas molecules are increasing in a chemical reaction, entropy is going to increase. Yes, why randomness is going to increase, we know that. Now they are saying if you have delta Ng greater than 0, then S is positive, right? If you have delta Ng greater than 0, S is positive. If you have delta Ng less than 0, that means change in the gaseous mole is less than 0, right? That means you have products are less as compared to reactants, right? Here you have products are more as compared to reactants. Here products are less as compared to reactants. Here products and reactants are equal. So in this case, products are more. That means randomness is more. More products, more gaseous moles. We know that more is the number of gaseous moles. More is the disorderedness. More is the entropy. Okay? More is the disorderness, more is the entropy, right? If you say that we have delta Ng negative, in that case what we say that Np minus Nr is going to be less than 0. That means Np is less than Nr, right? That means number of number of moles of product are less than, I'll write it here, Np only. Right? This is Np is more than Nr. This is Np less than Nr. Right? And this is going to be Np equals to, and this is going to be Np equals to Nr. Right? Okay? Understood? Yes, so everyone. So here you have entropy may be positive or it can be negative. Right? Okay, depending on the molecules. Next is we have the magnitude of the change of entropy may be represented by this thing, right? This can be represented by this thing. So this is the entropy change of the molecule. That will be always be product minus reactants. Okay, that will always be product minus reactants. Understood? Now, next is what we have, second law of thermodynamics. Right? We have different statements to second law of thermodynamics. This is not so important for you, right? But still, Clausius statement, it is impossible to heat to move it. It is impossible for heat to move by itself from a low temperature to a high temperature body. We always say high to low it goes. Right? We say it's not possible. This is the first statement. Second statement is that no process is possible in its sole result is the absorption of heat. Right? That only absorption of heat is not possible from a reservoir and its complete conversion into work. That only absorption of heat is not possible. This is Kelvin's statement. Okay? Boltzmann's statement is all spontaneous processes that are naturally occurring, right, are thermodynamically irreversible. Without the help of any external energy, a spontaneous process cannot be reversed. Right? We cannot reverse a naturally occurring process. Right? Okay? Thank you, Bacha. I am going to make more of that. Yes, I am going to make more of that. Don't worry. Yes, you just complete your exams. I am going to make more of organic chemistry sessions. That is why our target is to complete your syllabus in detail. Right, that we promise something and we are giving it to you, right? So we are going to complete your syllabus on time, right? And after that 1 month we are going to do full revision. Like revision, not only just formulas and all that, we are going to do practice sessions, everything we are going to do. Yes, okay? No, don't worry, I'm not tired. It's just that because of my arm, I'm feeling little pain here. That's it. Okay? I'm not tired, it's just that because of my arm, that is, this pain is going in my mind. So that is the reason. So I'm trying my, I don't want to take break now. Okay? Because this is the good flow that we are taking now. We'll take break if we need. Right? Okay? Yes, what is Vision saying? Thank you, Bacha. Thank you, Vision. Thank you so much, beta. Thank you. Thank you so much. Lots of love. Okay. No, it is not important. It is not important. Just that's why I told you that just go through the statements answer. Okay, not that important for you. Just this one thing, that the entropy of the universe increase in a spontaneous process and remains unchanged at equilibrium, right? That we say entropy of the universe increases. It is always positive, right? It remains unchanged in the equilibrium process, right? Entropy does not change in an equilibrium process. You have this thing. They say the entropy of whole universe is positive. Not system, not surrounding, whole universe is going to be positive, and at equilibrium, the entropy of whole universe is going to be 0 here. Yes? Okay? Thank you guys, thank you so much. Yes, that is my full-fledged energy. But because of this pain, I'm feeling little pain here. Not tired, but pain here. Right? Okay, so next thing is, second, when a system is in equilibrium, the entropy is maximum, right? When the system is in equilibrium, right, the entropy is going to be maximum. The change in entropy is delta S is equals to 0, right? If they say that entropy, if we say at equilibrium, the entropy is going to be maximum and this is going to be 0 at equilibrium. That we use in so many things, okay? We are going to do equilibrium next time, and here we will use this equation that delta S is equals to 0 at equilibrium, right? We can say that entropy for spontaneous process increases till it reaches maximum, and at equilibrium entropy becomes 0. What is important to you is at equilibrium entropy becomes 0, right? And delta G is also becomes 0, right? Next is spontaneity in terms of entropy change. If we say spontaneous process, we say the whole total entropy is positive, right? If we say non-spontaneous process, we say the whole entropy is negative. Okay, the signs are totally opposite to delta G, okay? This is totally opposite to delta G. So if you see this, I think there is a table for this, right? Okay. No. That is in the end, I guess. That is in the end. Yeah. That is in the end. Wait, I'll draw it for you here. Okay. That is for spontaneous. For spontaneous. This is for non-spontaneous. This is for non-spontaneous, everyone. So see this. Here we have, for spontaneous we have delta G is negative and here delta S is positive, right? And delta S is positive, right? And here we have non-spontaneous, delta G is positive and delta S is going to be negative. So they can ask you question from these statements, right? Okay? Yes, bacha? How to cover physical chemistry with a month in the time will be enough. Just watch my lectures. I am going to cover physical chemistry maybe in 10 days, right? Okay, I am going to do chemical equilibrium, ionic equilibrium tomorrow, and after that we are going to complete, after chemical ionic we are going to do solutions on Tuesday. Then we will be left with only 2 chapters. Just see my lecture, go through the PYQs, NCERT questions, and I think that will be enough for you given the time that you have, right? Okay, yes. Now next thing is calculation of delta S surroundings. What is the calculation of delta S surroundings, guys? So delta S surroundings is going to be the surrounding by T, right? So that is for system we have delta S surroundings is equals to minus Q of system divided by T. Now ma'am, how this came? Okay, very important formula. See, you have delta S surroundings equals to, just integrate this, okay? Just integrate this, you will get Q surrounding by T. And Q surrounding is equals to minus of Q system, right? The energy that you have taken from the system or you have given to the system, negative of that energy will be, if this is the system, it is giving the energy that I am giving, that will be minus, and the surrounding is taking the energy, that will be positive, right? So that is why I have written Q surroundings equals to minus Q system, always negative to that, right? The value is going to be same. So this is going to be delta S surrounding equals to Q system minus Q system divided by delta T. Okay, or you can simply write it here T, right? So this is a very important formula, right? Okay, so next thing bacha, we have calculation of delta surroundings. See, this is the state A, this is state B, right? So just simply write the formula here, right? If you have, so this is a state function. State function does not depend on the path, so we'll say irreversible is equals to reversible. So in that case, you will have this for the reversible path, right? Just I think this is an unnecessary slide here. I'm going to delete it here. You just need to remember this formula. That's it. Okay, just remember this formula. Just remember this formula. Okay, you don't need that formula. Okay, yes. Next thing that we have is Gibbs free energy. Next thing, bacha, that we have is Gibbs free energy. Okay, so the process of carbon in the form of diamond. So now, what is Gibbs free energy? What is Gibbs free energy? Everyone. What is Gibbs free energy? See, we know that when carbon is getting converted to diamond, there is a different arrangement, right? There is different arrangement in it, right? So carbon in the form of diamond turning into graphite is a spontaneous process, right? It is a spontaneous process. How it is defined? That delta G is equals to negative. That is how it is defined. So the Josh is high. I think my arm is paining a lot right now. I think I need at least 5-minute rest for now, because this is actually paining a lot. That is, I am not able to, give that much Josh here. So I think I need 5 minutes rest. Maybe 2 to 3 minutes, right? Okay, so firstly let us complete Gibbs free energy here. So G is equals to, this is Gibbs-Halbond equation, that is very important for you. That is delta G is equals to delta H minus T delta S. Now this equation, so many questions are asked from this equation. Okay? No, I will complete this chapter today. Okay, tomorrow I want to complete equilibrium, right? I have that target in my head that I have to complete that equilibrium. Okay, just pray for me that my health remains same, right? Okay, so now see this. Let's go to this. Okay, this one, delta G is equals to, this is a Gibbs-Halbond equation. Delta G is equals to delta H minus T delta S. Right? In this case, what we are going to see, delta H. If we say, so this question is asked so many times. This question is asked so many times in your NEET preparation. So many times in your NEET examination, they have asked this question. If you see delta H is equals to negative, if this is negative, right? So what is the condition for if this to be spontaneous or non-spontaneous? If this is negative, right? This is negative. And if we say this is positive, in that case, okay, in that this is negative, this is positive. This means this is negative, this is negative, this is negative, this is positive, right? So this means this whole will be negative. Delta G is going to be negative no matter what. In all the cases, delta G is going to be negative here. So that is the first case, right? That is the first case. Second, you have, if you say this is positive, if this thing is positive, right? If you say this is positive and this is delta, this is negative, right? This negative will be positive. So whole value is going to be positive here, right? So that is going to give non-spontaneous process. Now, if I say this is negative, now if I say this is negative, right? This is negative and this is also negative, right? This is also negative. In that case, this is going to be negative, positive. So that means this is going to be, okay. So now this whole value is negative and this whole value is also negative, right? Okay. So this is going to give us whole positive thing here. Now, if I say delta H is more than T delta S, in that case negative value will be more. So in that case it will be spontaneous. Okay, if I say delta H is more than T delta S, but if I say delta H is less than T delta S, okay, this is less, this value is more. In that case, this whole statement is going to be positive. So that is going to be a non-spontaneous process. Next is, if this is positive and this whole value is positive, If this is positive, this is positive. In that case, for this whole delta G to be negative, we need to have T delta S as more. Okay, T delta H should be greater than delta H. So that is a spontaneous process. If delta H is more than T delta S, in this case, that is going to be a non-spontaneous process. Yes, bachcho? Yes, everyone? Don't worry, don't worry. Don't worry about me, okay? I love this, okay? This makes me happy. This is my happy place, right? Okay? Yes, we have just few things left. Just few things left. Thermochemistry, very simple, right? So for the reaction, if we talk about this reaction, everybody in the chat box, okay? So for this reaction, the correct option is going to be, what is going to be the correct option here? Now we know that for this reaction, if I say here delta Ng is going to be 1 minus 2, that is negative, right? Delta Ng is going to be negative here, right? Okay, if delta Ng is negative, the correct option should be, right? If delta Ng is negative, delta U plus delta Ng RT. If this is negative, right? If this is negative, then this will be, wait. It's not about this. See whether this is an endothermic or an exothermic process. Okay. See whether this is an exothermic or an endothermic process. Everyone, see whether this is an exothermic or an endothermic process. Okay. Yes, bacha? Okay. Now, see, this, in this case, as we know, the atoms, right, they are getting converted into one molecule. So in that case, randomness is decreasing here, right? That means two atoms are combining to give one molecule, right? So the molecules is decreasing, molecule is decreasing, number of molecule is decreasing, randomness is decreasing. So I'll say delta S is this. And this is an exothermic process because to combine two atoms, two gaseous atoms, will need, like, this will release heat, right? When two atoms combine together, they will release heat, right? So this is going to be exothermic reaction, delta H is going to be negative here, right? Next, bacha, we have for a given reaction, delta H is equals to this much, delta is this much. The reaction is spontaneous. Assume that delta H and delta S do not vary with temperature. Now, what is going to be the answer here? For a given reaction, delta H is this, delta S is this. Okay. The reaction is spontaneous. Assume that delta H and delta S do not vary with temperature. Okay. It's a spontaneous reaction. That means delta G is going to be less than 0. Okay. And what is delta G? Just apply the Gibbs-Helmholtz equation here and you will get the answer. Okay. Just apply this equation here. You have delta G that is less than 0. That means delta H minus T delta S is going to be less than 0. Now, after that, equating this thing, T is going to be greater than delta H by delta S. Right? Just put the values here. You will get the value of temperature that is greater than 425 Kelvin. Right? Next thing, bacha, that we have is third law of thermodynamics. That means, that says that the entropy of perfectly crystalline solid, this is perfectly crystalline, no solid is perfectly crystalline. It's a very perfectly crystalline solid, may be taken as 0 at absolute 0 of the temperature. Right? This is an imaginary thing. Okay. So entropy of the perfectly crystalline solid, where the crystals have proper distance. Okay. When you study solid structure, you know what they are saying here. Right? If you have a perfectly crystalline solid, may be taken 0 at absolute 0 of the temperature. Right? If temperature is equals to 0 Kelvin, entropy is going to be 0 here. Next thing, bacha. Next thing that we have done these. Okay. We have done these. These all formula we have done. Okay. We have done these formulas. Next is thermochemistry. Okay. Let us talk about thermochemistry. Okay. Why the Josh is so low? I think my Josh is not low, but your chats is making my Josh very low. Right? I know some of the students are very busy in their board examinations. But yeah, the Josh is very low. Yes. Okay. Yes. When I will do redox, I'll do redox, after a week, right? I'll do redox with electrochemistry. Yes? Okay, everyone, I'll do redox with electrochemistry. Redox is a very simple chapter, right? Okay? Okay. They should not be busy at least 2 months before. Right? So let us talk about thermochemistry, as thermochemistry is very simple. Okay, you just need to, minus reactant, product minus reactant, that's it. Okay, so chemical processes are associated with energy changes in chemical reactions. Thermochemical equation represents both the material and the energy change. Right? A balanced chemical equation, first thing that you will do in thermochemistry is the balancing the chemical equation. Not only indicates the quantities of reactants and product, but also indicate the amount of heat evolved and absorbed. Now we will see how it indicates. Okay, so for example, they are saying, for example, you have this. Okay, this is enthalpy change. So enthalpy, just mark my words whatever I am saying. Okay, so enthalpy change is always product minus reactants. Okay, enthalpy, all the changes are product minus reactants except for one change, that is bond energy change. If you are breaking the bond, in that case you will write reactants minus products. Right? You will write that delta H is equals to products minus reactant, that is going to be enthalpy change. Right? Okay. So if the reaction is reversible, this sign changes. The heat is evolved, that is negative. The heat is absorbed, this is going to be positive. Right? So now let us see how the enthalpy changes changing the quantity. For example, this is here I am changing the quantity. Here I have used one hydrogen molecule. Here I have used double the amount of hydrogen molecule. Right? So what is the relation? Right? So if we increase, if we multiply this equation by x, right? This heat, the delta H will also be multiplied by x. Right? Okay? If the number of moles are doubled here, the heat energy change, the enthalpy change, right? That not heat energy change, the enthalpy change is also going to be doubled here, right? But now, if the physical states are changed, okay, if I am changing the physical states, this is to making H2 in liquid state, this is H2 in gaseous state. There is no relation here, right? There is no relation in the enthalpy change. If we are talking about the allotropic forms, if I am making carbon diamond and this is carbon graphite. If I am making carbon dioxide from carbon diamond or I am making carbon dioxide from carbon graphite, there is no relation, right? Okay, there is no relation in the energies. Only if you multiply the chemical equation by some factor, that factor will be multiplied to the enthalpy change. That is the only difference here, right? Next thing, bacha, that we have is the condition for pressure or volume. So, heat changes at constant pressure, constant volume are expressed as delta E, right? That is delta U. And heat changes at constant pressure are expressed as this. Was this a new thing? Right? We know that QP is equals to, QV is equals to, QV is equals to delta U, right? And QP is equals to delta H. This is what they are saying, right? Okay? Yes, bacha, understood? So temperature, heat of the reaction enthalpy also depends on the temperature at which reaction is carried out, right? Okay, so enthalpy of the reaction are calculated and expressed at a constant temperature, that is the standard temperature we take standard temperature, that is 25 degrees Celsius, right? Because that is also dependent on the temperature. Next is the standard enthalpy change, that is at 25 degree, pressure is standard, okay, all these things are standard conditions, okay, and that is represented by delta H naught, delta G naught, delta S naught, okay, we represent this by naught, right, okay, and what are the standard states? Standard state for sulfur carbon are carbon solid, carbon or graphite, these are the standard state. What about sulfur? This is rhombic sulfur. There are so many different forms of sulfur, right? Out of which rhombic sulfur is called the standard state. And what about phosphorus? It also has different states in which it exists, and out of which white phosphorus is the standard state here. Okay? Yeah, this chapter is kind of easy, right? So next is Hess's law. Hess's law is nothing but we have when we convert this, okay? When we convert this, okay? This is actually, if we say you're converting this reactant to product, this is a state energy. If I say this is 1, this is 2, this is 3, this is 4. I'll say 1 is equals to 2 plus 3 plus 4. This is the Hess's law. That if a chemical reaction can be made to take place in number of ways in one of several steps, the total enthalpy change is always same. It means the independent of the intermediate step, right? Okay, because this is nothing but this is, we know that this is enthalpy change is a state function. It is not a path function. That is how you derive Hess's law. Okay, right? Okay, this is how you derive Hess's law, because delta H is a state function. Now we know delta H is a state function. That means it is independent of the path. Whether this path or any other path, the enthalpy change is going to be same. Yes? Okay? Yes. Thank you, beta. Thank you. Okay. Next thing is, now calculate the standard heat of formation of carbon disulfide, given that the standard heat of combustion of carbon, sulfur, carbon disulfide are this. Very simple. See this. Okay. Firstly, let us write the equation here. They have given you calculate the enthalpy change of carbon and sulfur where you find carbon disulfide. Okay. You have to calculate the enthalpy change here. Now, you know one thing, that carbon with oxygen give carbon dioxide, sulfur with oxygen gives sulfur dioxide, and carbon disulfide with oxygen give carbon dioxide, and this. You have given the 3 enthalpy changes in the question. Okay, they have given you these 3 things. That the standard enthalpy heat of combustion of carbon, sulfur and carbon disulfide. Okay, this is given to you. Combustion of carbon, sulfur and carbon disulfide is given to you. So all these changes are given to you. Just need to apply the law here, right? Okay, how do you calculate this equation from this one? Okay, because it is independent. Enthalpy change is independent of the path followed. It does not depend on the path followed. So you can just need to multiply and divide this. Okay, you need 1 carbon, you need 2 sulfur. So multiply this by 2. If you multiply this by 2, this will also be multiplied by 2. Okay? Yes? And then what you do? Add this, then subtract this. Right? This is 2 plus 1. Then subtract this. Right? So what you need to do? Add 1. This is first equation. This is second. For example, add 1 plus 2 into 2 minus 3. Okay? Minus 3. And that way you will get your answer. In that way you will get your answer here. Right? Okay? Understood? You just need to multiply second equation by 2. Right? Then add 1 and 4th. Okay? Just add these 2 equations and subtracting the third equation. This is what they are saying. Okay? This is what they are saying. Add 1 and multiply. Multiply the second equation by 2, add the first equation and subtract the third equation. And this is the third equation. And similar way what you are going to do, the enthalpy change here. Okay, that means minus 393.3, then minus 2 into 293.72, and this is plus 1108.76. So this is going to be a total enthalpy change. This is going to be a total enthalpy change. Yes? Okay? Understood? Next we have enthalpy of neutralization. So all the enthalpies are same. Just you need to know what is neutralization. Right? Acid plus base, salt, that is neutralization reaction. Okay? So in this case also enthalpy change is going to be here. Okay? Very important thing. Here enthalpy change is constant. Okay, here enthalpy change, we're talking about 1 mole and both are strong. This is strong acid, this is strong base. then this is constant. Then the enthalpy change is going to be minus 57.1, and in calories it is going to be 13.7 kilocalories per mole, right? So for strong acid and base, this is going to be a constant value. This is also given in your practical chemistry. For any other combination of acid and base, this heat is less than. Why this heat is less than this? For any other combination. For example, you have weak acid plus strong base. So in that case, this weak acid, to dissociate this weak acid, heat will be required. So this heat, that is actually the heat of neutralization, will be used up by this weak acid. If you have strong acid and weak base, in that case, heat will be utilized by this weak base, right? To partially dissociate further. That is why if you have any other combination, weak acid, weak base, both acids and base are weak, or one of them is weak, in that case, heat is going to be less than this, right? Okay, yes. Next, bacha, we have bond enthalpy. Now, what is bond enthalpy, everyone? What is bond enthalpy? Yes, everyone, what is bond enthalpy? The amount of heat required to break 1 mole of bonds, right? To break. Now, this is very important. Here always we have reactant minus product. Here always we have reactant minus products. Okay, here always we have reactant minus product. For example, I am talking about this one. Okay, I am talking about this equation. Here I have this CC. This is double bond. Yeah, this is double bond. This is H. This is H, and this is H, and this is H, and this is H. Right. So what I will say, these are the reactants. So the bond breakage of C double bond C, bond breakage plus bond breakage of 4 into CH. Okay, the bond enthalpy of C double bond C, 4 into bond enthalpy of this CH plus bond enthalpy of H and Cl. These are the reactant minus product. That means bond enthalpy of Cc. So what is this C2? What is this C2H5 Cl? This is, okay, here you have 1 Cc bond, you have 5 CH bond and 1 Cl bond. So all these things will be subtracted. That means minus bond enthalpy of Cc plus 5 bond enthalpy of CH plus bond enthalpy of CCl. Okay, so reactant will be subtracted, reactant minus product. Okay, product will be subtracted from reactants. In all the other cases, what you will see that you always subtract product minus reactant. But in case of bond enthalpy or bond association energy, you will always do reactants minus product. That is the key. That's it. Okay, nothing more than this in thermochemistry. Okay, everything is same. Enthalpy of state change. What is enthalpy of state change? This is the fusion, right? This is enthalpy of fusion. This is vaporization, enthalpy of vaporization. This is enthalpy of sublimation, because solid is getting converted directly into gas, right? This is phase change. Now, what is enthalpy of dissolution? That when you are dissolving something, right? The amount of heat released or absorbed when the solution is diluted by adding water is called enthalpy of dissolution, right? Always we talk about 1 mole. Always we talk about 1 mole. Okay. Now the heat of formation, when you're forming something, the heat absorbed or evolved when 1 mole of substance is directly obtained from its elementary state. That I am forming carbon dioxide from carbon, its elementary state, right? Not carbon monoxide or any other state, right? I am making anything from its elementary state. That is called the heat of formation, right? By convention, heat of formation of an element is taken as 0. Okay. Now, what does this mean? Because they are saying the heat of formation of this particular thing will be taken as 0, right? This will always be 0, right? Heat of formation of any elementary particle, right, that exists as it is, that is taken as 0, because it is existing as it is, right? Okay, so this is also always product minus reactants. Enthalpy of combustion, when you are combusting something, when you are adding, when you are reacting this with oxygen, right? Okay, and giving it heat. In that case, that is called heat of combustion, right? So that is equals to also if enthalpy change when 1 mole of substance undergo complete combustion. Always remember 2-3 things here, that always we take 1 mole of substance. In all the cases we react product minus reactant, but in case of bond energy or bond dissociation energy, we write reactants minus products, right? So this will be product minus reactant, that is this is 2 into this plus this much minus this is going to be this is the reactants, that is 2 into O2 plus CH4. Now the reactant, the main thing that you are combusting, that should be 1 mole. Okay, not the other things. Okay, that should be 1 mole. Then we have calorific values, bacha. Then we have calorific values. So now what is calorific values? So bacha, amount of heat produced in calorie or joule when 1 gram of substance is completely burnt or oxidized. 1 gram of substance, okay? 1 gram of substance, right? If 1 gram of substance is completely burnt or oxidized, that is called the calorific value. If we say this is CH4 and it's 1 gram is completely burnt. See, here we have delta H is equals to minus 890.8. This is for per mole, right? This is for per mole. But if I say for 1 gram, now we know that the molecular mass here is 16, right? That is 12 plus 4, 16, right? If I am talking about 1 gram, in that case I will divide this by 16 and you will have your calorific value, right? So calorific value is what? Delta H divided by molar mass of that substance. Okay? Delta H divided by molar mass of that substance. Okay, bacha? So next we have relationship between Gibbs free energy, entropy and enthalpy chain, that is Gibbs-Helmholtz equation, right? That comes to what is the equation, right? This is the equation, okay? Gibbs-Helmholtz equation. Very important, we have already done this equation. Next, bacha, we have spontaneous delta G negative, this is this positive equilibrium. Okay, now let us do the wait. I think something wrong I have done here. Okay. I have added the PPT 2 times here. Okay. Change in the enthalpy for reaction. Okay, bacha. So what is the change in the enthalpy? If they are talking about enthalpy, that means product minus reactants. Okay. So the heat of formation of H2O2 is given to you. Heat and this is given to you, right? These 2 things are given to you. So what you will write here, everybody, we take heat of formation of O2 as 0. Okay, this is going to be 0 because this is in its elementary form. That is going to be 0, right? So what we will write, heat enthalpy change is going to be heat of formation of products minus heat of formation of reactants, right? Okay, so here we are going to do that. This is heat of formation of 2 into H2O minus 2 into H2O2, right? This is going to be your delta H. This is going to be your delta H. Okay, also see this. Okay, this is going to be your delta H. This is the same thing that I have written. Okay, right? 2 into delta H of wait. Here we should write H2O and here we should write H2O2, right? So for H2O you have 188, right? Wait, for a given reaction, wait, or change in the enthalpy of the reaction, heat of formation of this respectively. Wait, this should be products minus reactants. Wait, just give me a minute. because here H2O, okay? Okay, this is H2. Okay, now it's it. I just thought this is H2. I thought this is H2, right? Okay, so this is H2, heat of formation is this much. This for this heat of formation is this much. So we write minus 286 and here minus 188 and you will get your answer here, right? Next is on combustion. Next is bacha on combustion. What you have? On combustion, carbon forms two oxides, that is CO and CO2. Heat of formation of CO2 is this and that of CO is this. Heat of combustion of CO, right? Okay. So on combustion, carbon forms two oxides. Heat of formation of CO2, that is C plus O2, that is given to you. And heat of formation of CO, that is C plus O2, is given to you. Yes, bacha, this is going to be half. Now they are saying heat of combustion of O2, that is CO plus O2 give us CO2, right? You are given these two things and you are going to take the heat enthalpy change for this one, right? So what you are going to do? This is your first equation, this is your second equation, right? This is your first equation, second equation. In that case, very simple, okay, how you are going to take this? This is your first equation, this is your second equation, everyone. How you are going to take this? This carbon should be subtracted out, right? Okay, so just subtract 1 minus 2, okay? 1 minus 2 is going to be the answer, right? 1 minus 2, you will have your answer. For 1 minus 2, this is minus, this is minus, this is minus. You're going to, this will be minus, minus, this will be cut down, and this is going to be plus half, and this is going to be CO here, and this is going to be CO2, right? This is 1 minus 2, you're going to have your answer here, and 1 is this one, and this is the second one, right? So, this minus this is going to be your answer. So, that is okay, 1 minus 2 is going to be your answer, right? Okay. Yes. So, bacha, as you all know, we have completed this chapter. Just give me a minute. Yes. And for those students who are preparing for, okay, we have completed this chapter. For those students who are preparing for NEET 2024 and they need a crash course, like if you want that, okay ma'am, we want to polish our skills more, we want to be very confident on that, so everything is provided to you in this English batch, okay? This is the English batch, okay? This is an English medium. So here what you going to get, this is for just for 4,000 rupees, only for 4,000, okay? What do you get in 4,000? What you get in 4,000, this is your life in 4,000, right? Okay, so you have just 2 months left, right? So everything will be completed here, right? How things will be completed? All the sessions, all the things, all the chapters, all the important points will be completed. No matter, we are doing that on YouTube as well, but okay, we all know that in a very, in that environment, when you are in the app and you are, interacting with the teacher face to face, you are, you will be able to question your problems. You will have that doubt sessions, okay? That in right now what we lack here is that we do not do practice, okay? The theory part will be covered. That is okay, that is fine. Theory part will be covered, but also the practice sessions will be taken. The doubt session will be conducted, right? Doubt session will be conducted by us, right? So everybody do join this because you have just 2 months left, right? Okay, just 2 months. And this is not a time for hit and trial, like, okay, let's do this, let's do that. This is not that time, right? So do enroll to this session. This is not, and we are not demanding like 15, 20, 30,000. This is 4,000, right? And things, you will feel that offline factor. If we are giving you this quality for free of cost, what we are going to provide you for 4,000, you have no idea on that, right? Okay, yes. Now, next thing that we have is IVSAR. So all the students who are currently in 11th class and who are going in 12th class or who are droppers for next year, that means who are preparing for 2025 or 2026, they should enroll to this IV SAT registration. They should give this IV SAT test, where they will give the test according to their rank. Scholarship will be provided to them in offline centers as well as in online classes. All the when we release the course for the whole year, the scholarship will be provided to you there. Crash course scholarship will be provided to you there, right? All the things will be provided to you in that. Yes, and now one more thing here, that is this magic kit. Okay, just wait. So what is in this magic kit, bacha? What is in this magic kit? You have question papers of all the years. Like we are talking about 23 to 29 to 23 question papers. Then all the sets are included in here. Okay, all the code A, code E, P, W, and all the sets are included here, right? And how the PDF looks like? Wait. Okay, this is how the PDF looks like. Wait. Just give me a minute. Yes. Okay. So let us see how the PDF looks like. Firstly, let us see. This is 2017. This is 16. All the phases and codes are included, right? Question paper 2015. All the from 15 to 2023, all the question paper are provided to you. So now let us see how the question paper looks like. Okay, let us download any of this, right? Okay, so this is phase 2 answers and solutions, right? This is for your physics, and then you jump to this one chemistry, then biology, right? All the things are okay. This is for chemistry. You will see these the question papers of chemistry. Then these are you have bio, right? All the questions that are asked in bio, right? So you will get that feeling of the paper, right? You have the solutions, right? That are totally error free. So that is a request. This is free, right? That is a request. By I am requesting you, right? But yeah, that is an advice. I can only advise you right now. Even if now you are not serious for these things, that I don't know when you will be serious. I have no idea. After 5th May you will be serious? I don't know. Because right now is the best time to solve these question papers, right? To solve these kind of question papers, right? After that, go through the answers, that if you are correct or not. These are your mock tests. Daily solve one question paper. Only then you will be able to cover all the question papers, right? Okay, so that is my advice for you. Start at least in 2 days solve one question paper. In that case, you will be able to complete it by the end of April. If you start from now and daily solve the question papers, you will be able to complete in a month or so, right? So after that, what will benefit you? If you are able to complete this in 20 or 30 days, you will be able to see where are you lagging behind, what are the mistakes that you are doing. So improve those mistakes, revise everything again and again and again and again, right? That is my advice for you. Yes, bacha. Yes, question paper are totally free of cost. Yes, question paper are totally free of cost. You can see, just go through this, yeah, and then you will have this question paper. Download this, okay? Download any PDF from this, right? Start this, right? So everybody here, are you going to start this? Yes, that is my advice for you. This one, and also what are all the things? In treasure box, what you get? PYQs. If you are doing the question paper, that is a mock test for you, right? And then this is chemistry. In chemistry, what we have done today, we have done thermodynamics, right? Okay, let us see the NEET PYQ test. Okay, let us take the test. Okay, this is how you will give the test. Then give the test, okay? Then give the test, okay? Solve these questions, okay? Then you will be able to, understand if you have understood or not, right? How in physical chemistry, if you're not doing the practice, then there is no use of doing physical chemistry, right? So practice these questions and then come to this one. Then you have this chemical thermodynamics. Then you have CBSE questions. Now students usually ignore CBSE questions, okay? Do not ignore this. Do not go to some, right now you don't have time for any hi-fi book or reference book, okay? NCERT, PYQs and question paper of your NEET. That's it, okay? As my mock test, right? Okay? Yes, everyone. So this is your NCERT question. And this is your This is your NEET Thermodynamics PYQs. Okay, all in one. So you have revised this chapter today. First thing is go through the PYQs PDF, right? Next thing is do the NCERT questions. After that, give the PYQs test. These are the 3 tasks, right? It will hardly take you 1 hour, 1 to 2 hours, right? If you're going through that, right? Okay, because you have just revised it with me, right? So it will take you less than maybe 1 to 1.5 hours. That's it. Okay. After that, give the PYQ test. Hardly it will take you 15 to 20 minutes, right? After that, the confidence will be more. Now, whenever you are free, right, for 3 hours or so, give the question paper, or if you don't want to do the mock test, just go through the question paper, go through the questions, okay, if you want to save the time. And once in a week, pick any question paper and make it a mock test for you, like 2022 question paper, 2023 question paper, or any mock test, right? Okay, bacha? Yes, bacha. Thank you so much. Thank you so much. So all the best, bacho. Bye-bye. Take care. And do take care of yourself. Do take care of your health. I'll see you tomorrow at 1 p.m. Okay, I'll see you tomorrow at 1 p.m. What is the time, everyone? What is the time? The time is 1 p.m. Okay. Firstly, we will complete chemical equilibrium. Then we are going to complete ionic equilibrium. Yes, everyone? Yes, both we are going to complete tomorrow. Yes, I'll take break in between. After chemical equilibrium, I'll give you 20 minutes break for lunch. Right, then we will complete ionic equilibrium. Yes, bacha? Okay, ready? Okay, perfect, perfect. Okay then, see you tomorrow for equilibrium chapter. Bye-bye, take care, good night.